and he became an instrumental source, in building up lot of things the government, and that's why in recognition of his hard work he became the director of AIMS. He could not come because today is the convocation, because it's preponed actually from Wednesday to Monday. That's why he could not come. But I am very happy to announce that the Minister of Health, the Government of India, has agreed, for him to receive Sir C.P. Raman Award from KLU, but also to develop collaboration with us. So any one of you want to go to AIMS for training, for any of the visits, or understanding some new things happening there, you are always welcome. That's what you listen from his talk, And Dr. Srinivas is one of the youngest pediatric neurologist, and Deepthi madam is also youngest pediatric neurology from AIMS Mangalgiri. So he has that mindset, to develop research part. That's why now he is collaborating with number of institutions, including IIT Madras. Because I just want to tell you, in next coming 10 years, all IITs in the country going to have medical colleges, because they want to build an integrated innovative engineering medicine, which we started almost 7 years back in US when we were there. That time we brought a passion of the students. They do undergraduate pre-medical, then do 2 years engineering, they get MS, and then they will do 4 years medicine, an MD program for them. So that's why the doctors know engineering, and engineer knows about the medicine. So that was a kind of coupled system. So now India wants to build that kind of thing. That's why IITs are going to play a very important role. And then we are all crossing that borders now. See, many doctors going to learn many things, That's where we have the innovation, especially for young students belonging to pharmacy, biotechnology, or even engineering department. You have an opportunity to visit AIMS Mangalgiri. You have an opportunity to visit Andhra Hospital. Anywhere you want to go, please contact us. We'll help you, including AIMS Delhi, also many other AIMS, things. I also want to tell this symposia, has a very good opportunity, because we have a number of people coming from AIMS Raipur, SWIMS, Tirupati, and IIT Hyderabad, and also people came from Bombay. So welcome you all, in spite of all the traveling to this place. So this will become a kind of opportunity for our young students to become like a team, talk to the people, understand what is going on. Please visit, please see the places, understand what is going on in the country and what is going on in the world. Come up with innovative ideas. You have anybody come up with innovative ideas, I am going to tell you, we will give a special permission to work with anybody in this country. President of KL University is always open for that kind of mindset. Any student coming with any idea, we will support them. We will support them, not only linking them to different places, giving extra credits and other things. This course also carry credits. You get 2 credits is 42 hours or something is going to have. So every course we conduct now will have credit base. So you get extra credits for that. So please utilize this opportunity and then take advantage. Don't make listening something go away. Don't do that. Please understand and build your thinking. The inner power of thinking is something extraordinary, I tell you. You utilize that, open up that, talk to experts when they are here, or even by emails, or you have some idea, you want to talk to them outside, we will help you to send you, we will give you attendance. Okay, when you want to go outside, we will talk to the head of department, we will give you attendance, we do all the process. So KL is opening up new dimensions, not only people sending to within India, but also outside India. People are going to Harvard. There's one guy is doing University of Central Florida. We are sending it to France. We are sending many places. Only thing is you have to be something different. You cannot be a routine student, because you have to be something different. That means you think beyond normal. That's where we are looking for. And with these words, I welcome you all. And then I request all the students, youngsters, and even partners from other places who came. KL is open for collaborations. We have joint guides. Even a PhD student can have 5 guides. We have no problem. because we open up a lot of things, because our dream is student has to become something. It's not the number. Number doesn't make any difference. Like I have one student, I'm putting so many people guides. But I want her to get exposed to new knowledge and learn things. Starting from medical to professors in the institution. So KL President Satnarayana Garu always opened up that mindset. He says, let us implement this process. So we are opening. It's for you people to utilize. Now let us listen to the promises of Dr. Srinivas, who is the director of AIMS, New Delhi. Thank you.
Special focus on neurology. Ladies and gentlemen, our country is progressing very well. When we look at our lifespan, morbidity and mortality indicators, the GDP spent on health, the out-of-pocket expenditure which is coming up from the common man has decreased, and of course, the Ayushman Bharat Digital Mission, which is a big game changer for the country. The topic which have been assigned in applications of artificial intelligence in healthcare, with a special focus on our aims to make education. Well, you all know about what is AI. It's not just a set of mathematical equations and it is beyond, which involves a lot of machine learning and other things. Traditional software engineering, we were told the data inputs, applications of the software, and outputs and everything. But here we have a machine learning component which is over there. Evolution, as far as the AI is concerned, it has gone through the many evolutions for the past 50 years. The earliest of the things came the mammography and in the coronary angiographies, and of course, a lot of the included was that for the retina scans and diabetic retinopathy, and of course, radiology is the one area, pathology is another, ophthalmology is another one, where a lot of inclusion of AI modules into the therapeutics and the diagnostics of the various disease conditions was taken. Applications, there's a lot of applications of this. There will be a scope for artificial intelligence and second opinion. We are seeing that AI helps in triage. There are some tasks, superhuman tasks, which are there in the AI applications. Patient scheduling, we have seen that, how it is useful. The rapid reconstruction with respect to CT, planning, and MRI have come a long way for all of us in the healthcare system. The mammography, we will see how AIMS is using the AI mammography with respect to the dermatology investigations, the dental departments, and the volumetric analysis. All this has been seen here at AIMS New Delhi. We also use AI in the whole cancers. The entire world has the benefits of the artificial intelligence in COVID. especially the pulmonology with respect to the user detection and detecting the trauma hemorrhage and other things. Well, AI also is known for superhuman tasks. When we look into the various modalities, we have seen that these applications are very important for not only the diagnosis but also in therapeutics of the various conditions. Just to summarize what all the aims usually is doing, we have just enumerated here with respect to the various departments, the department of dermatology, how we are helping the diagnosis with respect to the mobile-based apps. So these are the funded projects, the various PIs, the faculty members who are involved with this. In the department of radiology, again, with respect to the mammography and the detection of the cancer, and in the biochemistry, we are looking at the various markers for the cancer detection. In the cardiology, there are three studies looking at the inflammatory cardiomyopathy, and in the neurology, with respect to the tremors and the various diagnosis with applications of the AI. In the department of medicine, there is AI with respect to the support system with respect to the ventilatory associated pneumonias. Early detection of them has a lot of implications with respect to the death rates in the ICUs. In the dental surgery, with respect to the diagnosis, planning of the treatment, and the various methods which are very critical with the inputs from the digital data. And in the radiation oncology, there has been artificial intelligence to manage the breast cancer patients. And to go back to the some more things with respect to the Department of Dentistry and Endodontics and the Department of Hematology, the Department of Pediatrics, there is artificial intelligence to look into the various neurological disorders of the pediatric neurology, especially the autism spectrum disorders. And in the pulmonary medicine, again, we have diagnosis with respect to the tuberculosis and the cancer, not only on the brain X-ray but also beyond. In the Department of Anatomy, AI is going to look into the various methods to look into what is happening with the healthcare workers and the students, and the pediatric surgery on the wound healing and wound infection. Various departments are there. Most of the departments are having AI projects and usually in the COVID, there was a lot of unprecedented issues. We were not prepared for things. There were a lot of deficiencies with respect to the resources that COVID struck us. So we looked into the AI to look into what are the methods which we can utilize it. One of the things was look at the just radiographs and also look into the CT scans to only diagnose and then predict the COVID prognosis and the diagnosis. This was the project with University with IIT Delhi, and our assistant professor Dr. Kritika was also involved with this. A lot of work has happened. We can share with you the publication. Some of these are listed over here. And then when we look into various departments, we have seen the publications coming out of the New Delhi with respect to the preventive and the curative intent with respect to the various conditions in various departments of the New Delhi. We all know that breast cancer is one of the most common cancer and it has the highest mortality. And the problem with us is that the outpatients come to us very late and it becomes very difficult for us to manage because the treatment changes and the death rates also change, the prognosis changes. So, and then in addition to that, with respect to mammography and early diagnosis, there are a lot of issues with respect to the experienced radiologists which is deficient in our country. We are looking at AI-assisted diagnosis and detecting the breast cancer, especially with the mammographs. And we are also looking at AI to train our young radiologists to look into the interpretation of the various mammographic images which we can take it from the remote areas. India has specific problems of the with respect to breast cancers, and we have less number of trained radiologists who can look into the mammographs and other things. And the specific issues with respect to it again that we have cancers which come very late, and there's dense disease which becomes a little issue for us with early diagnosis. So some of those topics which the HQLE is doing, has been shared with you in the table, and the various conditions are being looked into in the Department of Dermatology, where almost the tune of 40 different dermatological conditions are being diagnosed through a mobile-based app. This has been published from our side. And just to conclude, ladies and gentlemen, there's a bright future for the AI, especially in our country. The healthcare industry and healthcare needs of the country are going to be very much supplemented by AI, and we must utilize its potential to transform our practice in all the conditions which we are dealing with. And to summarize, that it is going to be very useful for not only the primary health, secondary health, and tertiary health. We have seen that how we can diagnose the dermatology conditions and also radiology issues at the various health levels. And it's not only useful in the preventive and also curative healthcare system. And we know that the country has a large population, a large number of patients, and some of our hospitals are overwhelmed by the numbers which produces the confusion in the tables, and the artificial intelligence is going to be useful to triage, to early diagnose, and to streamline the treatment modalities for our patients in our setting. And once again, congratulate the team that particular topic will be discussed. The experts are there who are the experts in artificial intelligence care, and they are going to have wonderful discussions to see that the country gets the benefit of the artificial intelligence. And my request to all of you to this the discussions today, that please collaborate with me. We have robust unit over here. We have an understanding of MOU with IIT Delhi also, and our faculty in most of the departments are utilizing artificial intelligence. And just to quote our Dr. Kritika Ragarajan, who is working with me from AIM with the IIT Delhi on artificial intelligence with respect to radiology. Once again, thank the organizers for giving this opportunity. Looking forward to see some of you at New Delhi so that we can collaborate, so that we can introduce our artificial intelligence into the various preventive and therapeutic modalities for our patients in the country. Thank you, Jai.
Distinguished guests, participants, and dear students, on behalf of the KL management and on behalf of all the participants, I would like to thank the plenary speaker of 5-day workshop, Dr. M. Srinivas, Director AIMS, New Delhi, for his valuable information, and also we would like to thank him for inviting for collaborations. And dear students, really it's a great opportunity to utilize that opportunity to have the collaboration with AIMS New Delhi. Thank you so much. Now, it's a great pleasure and we take immense pleasure to invite our keynote speaker of today's workshop, that is Dr. Srinivas Chakravarti V, Professor, IIT Madras, Chennai. Please welcome, sir.
So can we? Yeah. Video call. No. Video. HDMI, right? HDMI.
So even audio is there, sir.
No need.
Audio is
We can start. Good morning, everybody. Andarki namaskaram. First of all, let me thank the KL University administrators, the Chancellor, your visionary Pro-Chancellor, Dr. Jagannath Rao Garu. I really appreciate his vision and his dynamism, the way he's brought all these experts together and to a common platform and encouraging them to discuss and share ideas. Thanks to Dr. Basuja, right, and the students who are coordinating this, Soumya and others. It's a great honor and privilege to talk on this occasion. And also, there's such a warmth and affection in this meeting. It's like gathering of friends rather than a very formal, solemn, right, gathering of scientists and academics and all that. So let me talk this. I'm not going to talk about AI. I'll talk about fundamental neuroscience, some fundamental principles of neuroscience and issues about neuroscience. So I'll try to argue for a need to reform brain theory, right? Bring about some fundamental changes in brain theory, right? So when we say brain theory, first of all, let us ask what is theory, right? Because the word theory means different things to different people. If you talk to medical students, I mean, we don't have any medical students, but we have a lot of doctors here. And so for them, theory means is fat books, right? And they keep on by hearting all this pharmacology, anatomy, and goes on and on. And practicals means, cutting up, corpses and sorry, right? So that is practicals. For an engineer, theory is a very different beast. Theory is what you see on the left side there. Practicals means some circuits, some machines, motors, and etc. etc. So it means different things, different people. So now we started in IIT, we started a new department called Department of Science, Medical Science and Technology, where we are trying to bridge this gap. Because how come medical students don't learn math? And how come engineering students have no idea about how body works? Right? So you need to bring these two fields together. I mean, here this guy is saying, I have a knee problem, and knee is, telling its own problems, right? So why should you bring math into medicine, right? Because these two fields are always separate. Because if you're scared of math, you go to medicine, and if you hate biology, you go to engineering, and that's a standard thing. Why should it be that way? So in fact, I had this blessed opportunity to teach my wife some physiology many years ago when she was studying for her medical exams, and I was teaching all the physics. She says, "Why do you teach me physics? I don't need this. I'm a doctor, right? Just teach me the basic physiology. Physiology is all physics, right? But so now you start asking question, what is a mathematical model? Why do you even need it? Right? In your plus two, you must have studied about projectile motion, simple pendulum, simple harmonic. You must have done all that and passed in lots of exams and all that. So that is math. You know that. You know how math can be explained, can be used to model, to understand physical processes. It's well known in at high school physics level. Medicine is not different actually, but if you look at physiology, you want to understand lung function, you will use PV equal to nRT, right, to understand how pressure and volume change together. Or you look at blood flow in a vessel. That's like a fluid flowing through a pipe. You'll use Poiseuille's law, Bernoulli's law, and all that stuff. It's not different. It's a physical process. So human brain is also not different. I mean, people make so much song and dance about brain being so complex and more complex organ in the universe and all that, which is, I think, silly. It's like a lot of drama about it. Brain is also a big electrical circuit. If you and try to look at a single neuron, it's like a circuit, right, which I've shown on the left side. And the way signals propagate on a neural fiber, a nerve fiber, it's very similar to the cable equation that you use in electrical engineering. So thing is, brain is a physical system, so it obeys the laws of physics, at least as far as we know, right? So therefore, what is brain theory, right? We can define it like this: a field that describes the activities of the brain using mathematical models, and then program them on a computer, right, using your Python or whatever, and use such computer models to understand brain in normal and disease conditions, and then use it for treatment subsequently. This brain theory, and this has a more formal term called computational neuroscience. So this is a field that has seen explosive growth in the recent decades. The origins, you can trace it back to 1940s when McCullough and Pitts proposed a simple neuron model and tried to understand brain as a computer and all that. Or the major finding was the model of a neuron proposed by Hodgkin and Huxley in the 60s, for which they got a Nobel Prize. Right. So it's at least like close to a 80 years old field, right? There are lots of conferences that are going on. Lots of literature is just exploding. Lots of journals and books and so on and so forth. But right, and there are deep issues. That's what I want to focus on. Because all the celebration and festivities, I mean, we know that, right? We do that all the time. But what is the underbelly where there is something missing? There's a vacuum. Right? That's what I want to talk about. These issues lie in the way, I mean, lie in probably in the very nature of biology. At least biology, as we deal with it, as we organize the data in biology, right? The very nature of the field pose and fundamental challenges in the way we understand biological systems. So first of all, biology is very descriptive, right? I mean, how many of you remember your experience of writing some biology records? Right. In my eighth standard, I remember we plucked all sorts of leaves from nearby trees and pasted them on papers. And this is Ziziphus zigiba, and this is something else, right? Malvasia, Mictaceae. Why do you mug up all those names? What does it tell you about the nature of that leaf? Nothing, right? Why spend so much energy and time and wasted paper and carbon emissions and all that on an activity which is completely empty of substance, right? Why do we do that? Why do we do so much of that? Now, this is a picture drawn by Antoine von Leeuwenhoek based on his earliest observations of microscopic life. Right, he has just made this very crude microscope, took a slide, took some dirty water from a nearby pond, put it under the microscope and observed what he is looking at and made pictures of it. Very beautiful diagrams. Of course, real microorganisms don't look like that. They look like some fantastic creatures from some science fiction movie, right? But anyway, it's a very good attempt because it's a hand-drawn picture. And they're very beautiful, but point is it's just description. And description doesn't give you insight into the nature of those microorganisms. But I guess that's how you start, right? Now, regarding this side of biology, this descriptive nature of biology, this guy called Yuri Lazarnik wrote a very interesting article. It's a quite a hilarious article that says, "Can a biologist fix a radio?" Or what I learned from studying apoptosis. This was published in Cancer Cell. So the article goes like this. I didn't make it out. I wish I had written that article, but so the article goes something like this. Suppose you ask a biologist to fix a radio, right? In biology, if you want to fix something, like you want to fix a cancer, kind of cancer, how do you proceed? You first find out, create a cell which expresses that certain cancer gene or something, and then you take a lot of samples of that cell and do some assays and find out what's going on, right? Take the same approach to radio. What do? You buy lots of printed circuit boards of that radio, buy some 10,000 copies of that. And then the earliest first stage of study would be what is called structural analysis. So you do structural analysis of the circuit board. How does it work? Okay, I look at this circuit board and I see there are blue cylinders. There are two of them. And the cylinders height is 1.1 centimeters. Diameter is something else. And it has a silver head. You note down the color, and then there's some text printed on it. You note down the text, and then there are certain red cylinders with a rounded end. Right, you note down their shape, and then there are some cylinders which have stripes on it. Some have 4 stripes, some have 6 stripes, some have multicolored stripes. You note down the colors, and this will take a long time, a very very long time. So people spend a lot of money, have postdocs, 7 postdocs in a lab, and graduate students and technicians, JRFs, huge empire, And so this goes on for 10 years, and they finish a very elaborate structural study, write lots of papers published in Nature, Science, and so on and so forth. Right? We still don't understand how radio works. Okay, so but structural stage goes for 10 years. Then you come to functional study. How does functional study work? Okay, now you power on the PCB, connect it to the power lines. Now you want to understand which of these components is contributing to the sound coming out of the radio. What do you do that? Okay, all things being equal, I remove things one at a time. I pluck out one component. What happens to the sound? No change. Okay, put it back. Next component. Listen to the sound. Nothing happens. So it's a very robust system. Usually doesn't break. Then you pull out some key wire which carries power from the power lines into the PCB. Sound completely solved. No power. Right? So that becomes a major discovery, and everybody gathers on, what happened? What happened? I pulled up this line, this blue wire, and suddenly the sound stopped. It's like a key gene, right? A key wire which controls this whole, sound coming from this machine. And that postdoc becomes a star in that lab. and the postdoc gets faculty offers from Stanford and MIT and all that, and NIH pours money, right? And then this guy's career is set. I mean, for 10, 20 years, his career is, his or her career is set. Now, point is, as an engineer, if you look at this whole process, it looks silly, right? Because what does a radio mean for an engineer? You need to know a couple of things. First of all, for radio, to even talk about a radio, you need to have some idea of an electromagnetic wave, and the idea of a message signal which rides on top of a carrier wave. That carrier wave has a fixed frequency, and that's what gives you this kind of a hotline between the receiver and transmitter. And at the receiving, you need to have some kind of a resonator. I don't care how you implement it. You can implement it in 20 different ways. They have a resonator which resonates with that carrier frequency. Then you demodulate that signal, amplify it, put it into a speaker. And what amplifier you use, what combination of modules you will use, all that is detail. You work it out in your leisure. But broad organization is there is a carrier wave carrying a message signal coming in. I have a resonator, I pick it up, demodulate it, positive amplify it, feed into speaker. Rest is detail. It will change from your radio to radio, company to company. If you don't have this broad big picture, all the structural analysis will take on forever. It might never, not even succeed forever, because you haven't got the big picture, right? I mean, imagine this perspective, apply this perspective to the way we do brain research. It looks scary. I mean, even the success, whatever success we had in completely serendipitous. I mean, it just got lucky with that kind of a terrible approach. You approach, so you try to understand brain science, and we are lucky, here and there we got good success. I mean, this doctor is able to make patients walk literally, right? The lady is just literally crawling on the steps and with DBS on, so suddenly, that's miracle. Nothing less than a miracle. The hit and trial approach, you are able to do that, it's still miracle. But what if you could understand brain the way we could understand the radio circuit? I mean, that completely revolutionized the field. That's what I'm talking about. Even with this purely empirical hit and trial approach, with massive amounts of investment and effort, we're able to work miracles. What kind of a revolution we'll be achieving if you could understand brain thoroughly the way an engineer understands a machine? Right? That is the essence of my talk. So that's not the only thing. So another factors which are contributing to this completely empirical trial and error based approach. Even AI is actually part of that whole approach, right? Because it's a completely data driven approach. Is that we are living in the era of big data. Because this whole workshop is about AI, which means data, right, modeled into some kind of a empirical form. So if you look at the whole fundamental pillars of science, right? All science begins with experiment. The experimental science starts first, and there will be typically a long stage of experimental science. People keep on observing, organizing observational data, and so on and so forth. After a long time, people try to connect the dots using some kind of a mathematical theory. I mean, even the last few thousands of years of science, if you see, this is what has happened. But then the theory becomes more and more refined and becomes more profound. It will gain depth after some centuries of effort. After that, then most recent pillar is computation, like about 50 years of this thing. And after that, even more recent is the data pillar. So now we talk about the fourth pillar of science is data. What is this data? The idea is that since a lot of physical systems are extremely complicated, we can't wait for theory to become mature, where that will take forever. Right? We have a lot of technology, we have equipment, we have funding. So just keep on collecting data, right? Put it in your hard drives and pile up hard drives. And once one of my colleagues from US University was complaining, I don't even know where to put hard drives. Right? No, who asked you to make all those hard drives? Okay, that's a different question, right? So what is happening is, because we have the technology is getting refined and more refined. In fact, I'll tell you this. It's a very nice book called Connectome, written by Sebastian Jung. So this Jung, when he was young, he asked a mentor, right, what kind of work should I do so that I'll have a career and become famous and all that. He says, build a new method, create a new neuroscience method. Why is that? Because if you create a new neuroscience method, everybody will use your tool and they'll cite your paper or papers. You'll get high citations. What kind of an approach to research is that? I want to understand deep questions and solve problems, not somehow get citation index, which is a silly objective, right? But that's how the world is running right now. So because of this approach, you have take any level of of detail in your brain, right? The lowest level is molecular, cellular, and circuit and systems, and right, and then behavior at the end. So at all these levels, we have practically infinite amount of data that's being churned out by labs all over the world. right? I mean, name any level and you can just Google for it, you will find the data. Take, for example, neurons, single neurons. Now, neurons are a very beautiful class of cells. Like any other cell, they also have membrane and cell membrane, cytosol and nucleus, the same genome in a given organism and all that. But what is so different about them is all these wires sticking out, right? I mean, a single neuron can have typically 1,000, 10,000 connections. Or the extreme, this hairy guy like the Purkinje cell can have about 1 or 2 lakh connections. Single cell can have, if your mom sees somebody like this, he'll say, go get a haircut, right? So that's the kind of neuron you have. So all these people have created atlases of these kinds of neurons. Right? Given neuron, okay, how many wires does it have? What is the branching pattern? What is the thicknesses? What is the lengths? Right? And what is the conductances and ion channel distributions and receptor densities? Oh, name it and you have it. You have atlases published with that kind of data. If you go to the next level, for example, take the Connectome project. I was just talking about this book called Connectome. World over now, there's a big race to get very detailed models of brains. Right, ultimately, we would like to have it for human brain, but if human brain is very complicated, it's 100 billion neurons. So we'll start with a simpler organism. But the idea is to understand the entire neural network of the brain. People have done it for a small organism like what's called a C. elegans, which is more commonly called nematodes. So small you can't even see it with your naked eye. You have to see it through a microscope. This organism, fortunately for us, the connectome guys, has only 302 neurons and about 7,000 connections or so. This is completely mapped and it's a beautiful piece of work. Now, with that, people want to jump to human brain. The Connectome project aims at building that kind of a model of the entire. So, human brain is a graph of 100 billion nodes and if you like a quadrillion connections. You want to work out the entire graph. The point is, why? What is the hurry? Right? Can we first understand the logic of neuroanatomy, the logic of brain? Why is it the brain the way it is? No, we don't ask why in biology. We just measure it, describe it in great detail. Now you have 3D models of brain, we have technology. No, you just open it. No, I don't want to understand like that. I want to understand why is it like that. Let's start with the basic question. Why does brain have 2 hemispheres? Why can't it have 4 chambers like the heart? What is that two? And why does it have this kind of a bilateral symmetry? Let's start with that very basic question. Now, if you think about it, it's not very hard to answer this question. And because body has bilaterality, and then you can ask, why does body have bilaterality? You can argue, I mean, if evolution, your reptiles will go through this fluid media, and if the body is wide and flat, it's very hard to push to the resistance of the fluid media. It has to be like a tube, like a submarine, right? So bodies are like tubes with a pointed nose. And that's physically, that's a very natural thing to plow through a resistive medium. And through evolution, that pattern, that body plan has survived. So you end up with 2 legs and 2 hands, very natural. So a brain that is innervating that kind of body will also take on that same shape. It will be bilateral symmetric. Okay, that is fine. Okay, I buy the argument. What about this strange feature called cortex? Why should you have this sheet of neurons on the cortex? We still don't know. Last night we tried to figure out over the dinner, right? We were too hungry to think much about it. We couldn't crack the problem. We still have a long way to go. What about cerebellum? Why is cerebellum outside? Why is the thalamus inside? Why can't I put thalamus outside and run fibers into the brain? Who makes all these decisions about brain's organization? All right. So can we understand brain at this fundamental level? So the day I would feel that I understood brain's anatomy is right. I mean, somebody like in a God, it will ask you to design a brain. Okay, this is new animal just come, design a brain for it. Or I'll say, okay, I'll have this kind of a cortex. I'll have 3 thalami, whatever, right? And then my simulation runs it and then optimizes something and then gives you a brain design. We are not nowhere near that kind of a goal because we just worship. Okay, nature has created this. We worship it and just try to reproduce it, try to measure it, observe it, forever. So because of this kind of approach, what's happening in neuroscience is we have tons of data but very little theory. Huge data, e to the mc square is like very small. And this is actually not surprising because if you look at history of science, history of any field, the way any scientific branch grows, this is exactly how it grows. So let me take a little story, my favorite story about history of astronomy. So we all know that in your high school, we all studied that, there was a time when people thought Earth is the center of the universe, right? All the planets and sun go around this thing. So, like even way back 2000 years ago, Ptolemy, for example, the Western observation astronomer. So he thought, he looked at the planets and the way they move and all that. And when you think of Earth as center and look at the planets, their motion will look very complicated. They're not they So he described them using something called epicycles because it won't look simple circular. I mean, you'll have very complicated wavy motion. So then, a few centuries ago, Tycho Brahe, the Danish astronomer, he had a lot of funding, right? In fact, by the time of Tycho Brahe, which is about 1500s and so on, the models of astronomical objects, the heavenly bodies, right? They were quite erroneous. Like if you want to predict an eclipse, it is off by a couple of days, and that was very bad because they were using astronomical data to predict things like should the king go for war or not? Will he die if he goes to war now? Right? People are mixing astrology and astronomy very freely. So you need to get your predictions very accurately. So what is the approach? How did you solve the problem? You would first, there are two options. Will you question the paradigm? Are our predictions so bad because our paradigm is wrong? We are thinking Earth is center, not sun. It's not sun. Therefore, maybe our predictions are so wrong. That is one approach. Other approach is maybe we don't have enough data. Right? Just get more data. Fit your cows more closely. Then maybe your predictions will get better. Which is the better approach? Now we know what's the better approach. Even a child will know. But then what Tycho Brahe did is, let us get more data. How to get more data? Get more funding. He had king's patronage. Danish king patronage. He got bigger telescope. He got lots of students. They said instead of observing the planets once every week in your leisure time, every day go up and then every night, right? Observe the planet every hour. Right? Increase your sampling rate. Increase your data. No different from I have this NSG sequencing machines, right? That we can screen every genomes, like 10 genomes per day. Is exactly the same thinking. So they've done that and they've improved the predictions, but the paradigm hasn't changed. Or paradigm has changed a little bit. It became even messier. What is the paradigm that came after Tycho Brahe? He said, okay, fine. Earth is the center, because if he doesn't say Earth is center, church will shoot him. Right? So he had to say Earth is center. But Earth is only partially the center. So Earth is center to what? Sun and moon. Sun and moon go around the Earth. And then the other planets go around the sun. What is that paradigm? It's a completely political paradigm. It's a political compromise between a science, a growing science, and an entrenched tradition. Right? That's a paradigm. So paradigm for him is a non-issue. Right? It's irrelevant for him. Data alone is important. So he might have improved his prediction accuracy a little bit, but paradigm-wise is completely off. Okay, and then around the same time, Kepler also lived. Kepler is a poor guy, so he's not in a position to do any experimental work. Right? He was literally going around place to place with his begging bowl. He couldn't even feed his family well. Right? And this chap who had a lot of funding, Tycho Brahe, wouldn't even part with his data, so Kepler can analyze and make some models. So Kepler started as a theoretician right from his young age. He wanted to understand the logic of planetary orbits. The way he started is because his theoretician is very fond of mathematics, and he was fond of geometry because Greeks used to believe that God is a geometer. God designed the whole world based on the foundations of geometry, and so everything used to have a geometric explanation. Why are planets round? Because sphere is a perfect shape. Why are orbits circular? Because circle is a perfect shape, and so on. So it's like very silly. So he started with this idea of regular polyhedra. There are only 5 regular polyhedra, and he makes this very complicated construction. Start with a sphere, and circumscribe it with one polyhedron, and then another sphere, another polyhedron. With this complicated construction, he kind of proposes that the radii of these 6 spheres is proportional to the radii of the orbits of the known 6 planets. He did that, but actually it's not a very accurate fit. But later on, he kind of stumbles upon this idea that planetary orbits could be ellipses. And with that, he then goes and analyzes existing planetary data and proposes these 3 patterns, right, which we know as Kepler's law. So you see the evolution of science. You start with observational tradition, which goes on for centuries and thousands of years. Even Polynesians in the southern Pacific, they had a rich tradition of astronomy from about 2000 BC. Right? Ancient India had, we know which is quite alive, the tradition of astronomy. Because in this tradition is you observe and then fit trigonometric time series. There's no laws of physics underlying these kinds of models. but that itself has some utility. So Kepler had this, and then Newton came along and saw these three laws, and you could see the underlying physics behind these three laws. Right, it must be happening because sun is a gravitating source, and the gravitation decreases with distance, in inverse square fashion, and so on and so forth. He could propose that, and then he could explain all the planetary orbits very beautifully. That Newton's laws was so successful that at that time we knew only this first five visible planets, right, for a long time. We didn't know Uranus and Neptune and all that. How did they find Uranus and Neptune? Not by incessant observation. When Newton's laws were showing deviations of orbits for outer planets, they said this must be coming because of an unknown planet, hitherto unknown planet beyond Saturn. And they could even predict where it should be, what should be its mass. Right? And then that's how they kind of guessed there should be a planet here, and then they saw it and looked for it and they found out. Through telescopes, of course. So the theory, once it is perfect, once it is mature, it will be so good. Right? This kind of an infinite amount of experimental work may not be necessary if you have good theory. So what my dream is that in my lifetime I would like to see this change. On the right you see this famous textbook of neuroscience called Principles of Neural Science. This is a picture of 6th edition. So there's a British motor functions expert who jokes about this. It says Principles of Neural Science. Any book on principles should be very thin. Right? Because principles are always few. This book's getting fatter and fatter with every edition. How is it possible? How can that be a book on principles? So it's a mixture of a lot of data and principles. We are not able to really understand, filter all those principles and distill all the principles. On the left, you see the picture of Newton's Principia Mathematica, Philosophia, Naturalis. And his grand vision of the universe has a nice clockwork, right? All the math he has developed, the calculus and all that, is captured in one book. And that one single book created what is we call the Newtonian revolution, which changed the whole flavor of science all these centuries. Of course, until Einstein came, that theory stood its ground. Even today, it's a very good approximation. For all practical purposes, for satellites and all that, I don't think we use general relativity. I think Newton's laws are good enough. So that is the power of theory when you have it. And in neuroscience, we don't have it. We have only bits and pieces of it. We don't have a grand, streamlined, beautiful theory of the brain. But it's worth working for it, worth searching for it. Because once you have that kind of a theory, next few centuries will be very different when it comes to neuroscience. So people are expressing certain kind of dissatisfaction about this lack of good theory in neuroscience. Take, for example, the Indian origin scientist Dr. V.S. Ramachandran. So he says that we are at the Faraday stage in neuroscience, right? Or take, for example, Patricia Churchland. He says there are no good neural theories. There are theories, but no good ones anyway. So another problem lies in the fact that biology is essentially reductionist. That means you would like to explain all phenomena in terms of the smallest constituents. In a biological system, what are these constituents? Cells and molecules. So any problem you want to explain in terms of cells and molecules. You pick a disease. Oh, why does diseases occur? Oh, because of some gene mutation. Right? And then you try to go all the way from gene to some symptom. Right? Whereas in engineering, we don't try to explain all phenomena in molecular terms, or in terms of smallest constituents. Take, for example, the problem of designing aircraft wing. Right, you want to understand how wind blows on the wing and produces lift and drag and thrust and all that. Right. For that, we don't try to do molecular dynamic simulations. I think that Pratiti will tell us, right? Because if you do molecular dynamic simulations to understand the action of wind on the wing design will never be complete in this century. It will take another century. So we talk about fluid dynamics. We use something called Navier-Stokes equation. That's good enough. In there is we are not mentioning molecules at all. So in engineering, we understand this idea of abstraction. The right abstraction for the right problem. We don't always go to the smallest level. Therefore, we're able to design and operate systems quite effectively. Whereas in biology, you want details and you want to also go to the smallest level for everything and explain everything in terms of smallest level. The problem is rendered harder than what it actually is. Right? So, like I said, we have a lot of data in all these levels. But since we don't understand how all these things work, we don't have a right abstraction. Diseases are not well understood. So, for example, take any of these, what is the so-called multifactorial diseases. Take any major brain disorder. I mean, pick anything. Right? We don't have a good treatment. I mean, I can challenge. So it's all very uncertain. If he, I don't want it. I'm an engineer. Treatment fixing. If I give a car mechanic, mechanic can't say I'll replace this part. Let us say come back after 3 months, and if otherwise I'll replace another part. That's not. Then you don't know how the hell it works. If you know, tell me exact diagnosis, fix it, bring it to me, working condition. That kind of knowledge of brain we don't have. So we do have miraculous treatments, and like God, this treatment works in miraculous ways, mysterious ways. I'll tell you some examples. Vagal stimulation. So vagus nerve is an atomic nerve, is a parasympathetic nerve, which acts on the heart and many other targets in the body. For example, if you activate vagus nerve, that will slow down the heart. If you activate too much, it can even stop the heart, which can be dangerous. But we do vagal stimulation for epilepsy. Epilepsy is like a cortical phenomenon, huge, synchronous activity all over the cortex. Why does it even work? But it works, we use it. Okay, we'll figure out what the calibration, what is safe, current levels and all that. We use it, works. Take depression. Depression is a whole different ball game. Why are we stimulating vagus nerve? I don't know. It works, right? So look at this article in Wikipedia. What it says: as of 2017, just recently, little was understood about exactly how vagal nerve stimulation modulates mood and seizure control. Okay, but we use because it works. Take for example, lithium for bipolar disorder. Bipolar disorder is a mood disorder where the patient switches between mania and depression. And before treatment for 70 years. I don't know if you are into watching TV, if I might have seen Homeland, where the main character in Homeland has bipolar disorder. She keeps taking lithium medication. It works to some extent, and in fact, I think that's the best bet we have for BP today. And again, exactly how lithium works to do this is not known, though. Okay, so let me give more examples. There's a beautiful book called Prescriptions for the Mind, written by an American psychiatrist, Joel Paris. He says in this book, I'm quoting from page 113. By 72, psychiatrists had a useful armamentarium of drugs falling into 4 groups: antipsychotics for schizophrenia, tricyclic antidepressants for depression, lithium for mania, benzodiazepines for anxiety and insomnia. With these agents, we could help many, if not most, of our sickest patients. A beautiful development, right, in the world of psychiatry. One should keep in mind that we do not know how most of these drugs used for mental disorders work. It is entirely possible, however, that advances in neurosciences may lead to further breakthroughs in pharmacotherapy. So again, he said we can all discover better drugs, right? But he never says we could understand their action. By understand the action, I don't just mean like in a very vague hand-wavy term, like lactone, right? Cytomate, lactone, dopamine. That's very vague. I don't want like that. I want to know exactly where all, and then what happens there, and it activates. It alters the activation of some cell. That changes the activity of local circuit. That changes the activity of a downstream system, and that all the way to how I wave my hand, how my liver function changes. Thorough understanding without leaving anything to guesswork. That's understanding. And we're very far from that. So on one hand, you have all these problems, and other side, if you look at the human side of what happens, right? I mean, people say, "Oh, we found some new gene for some disease and all that," and it comes in papers. But what actually happens at our level as layperson, as normal human beings, right? The other day, I was in San Francisco Bay Area. I was going on this ferry because I like water. I like water bodies. I was seeing this woman with a neuroscience book, in her hand. I thought she was some neuroscientist, and I started chatting her. She said, "No, I'm not a neuroscientist. I'm just interested in this field because her husband apparently has stroke. Had been living with stroke for last 18 years. Is confined to a wheelchair, and they have 2 daughters. So this lady practically single-handedly brought up the 2 daughters. They're now in college, they're married, and well settled. But imagine the kinds of uphill tasks that she has been facing for the last 2 decades, right? Because we don't, the treatments work in some places, they don't work, right? And that's all. Take even more fundamental. Now it is coming down, but take mental retardation. In fact, you're not even supposed to use this term. There's some sensitivities about it. Okay, I don't care about the politics. The problem is living, is there, right? When you see a person who's mentally retarded, and they're left so financially okay, but they live for 80 years, 70, 80 years. What kind of life is that? And what can you do for that person? Right? The understanding of brain wanted change things for that kind of a person. If you can intervene very early, not by throwing some random drug. I'm not talking about. We need to understand fundamentally what is wrong with that brain and look for change in paradigm. Or take traumatic brain injuries, very common. Road accidents are so common. And once it hits the brain, right, the personal changes are very profound. I mean, I know personally people whose life has completely changed. The way they act, the way they think, their participation family completely changes. Because when you see some broken bone, you can understand that. Because I mean, when you see a broken brain in an accident, the effects are more lasting and more profound. So I feel because I'm an engineer, I approach things in certain fashion. I'm saying, okay, good brain theory will change things, but other people can have other kinds of approaches to it. So how are we doing on time? Okay, okay. So I feel that this brain theory also, if you take the approach of engineers and physicists and take that kind of approach to brain theory and build brain systems, right, model brain systems, that will bring about a lot of change in the way we treat brain, the way we understand brain disorders. My lab's goal is to, and hopefully by the time I retire, that's another 10 years to go, to build a simplified model of the whole brain. It doesn't have to have 100 billion neurons, even with 10 million neurons. In engineering, whenever you want to build a large, like a bridge or something, build a prototype first. You don't go out and start building a real bridge. And then you test the prototype thoroughly in your lab, and then you start building the bridge. Same thing with the brain. You build a prototype with 10 million neurons, test it thoroughly, every aspect of it, and let it actually manifest and express understanding of at least 10 major disorders, right? And we should know how hippocampus was, how basal ganglia was, how cerebellum was, everything in that one prototype. You shoot down that model with every possible test and see if it withstands those tests. Only then you start using it in outside. So we call this kind of imaginary brain model the mesobrain, because in this brain we don't go all the way to molecules and all that. It's slightly abstract model. It will have sensory inputs, ascending sensory streams, and descending motor streams. Between these two meet in this big decision-making system called the prefrontal cortex, with all its components, dorsolateral, prefrontal, and so on and so forth. And then you have these three major loops: cerebellum, basal ganglia, and hippocampus. If you can capture these, this itself is a tall order. It's very hard to get all these things things right. That will be a beautiful kind of a simplified model of the whole brain. So that is a kind of holy grail, because I read in some of these management books that if an organization has a central goal and everything that you do is targeted towards that central goal, that will create a lot of energy in the organization, unleash a lot of creativity and so on. So that with that idea in mind, we said, okay, this is our goal. Whatever we do, we'll try to direct it in that direction. So we are now, we've been building models of various brain systems. The idea is that we'll assemble all these systems sometime, before I retire or even after retirement, right? And build the whole brain model. So for this, you need to have a rightly simplified view of the brain. I've written a book, but obviously this is hardly sufficient. So the lab has been working on modeling the basal ganglia, modeling hippocampus, stroke. So I'll talk quickly about some of these efforts. So we've spent a lot of time on modeling basal ganglia. So for those of you, obviously, a lot of people here are from engineering. So brain has this it's a collection of neurons connected by wire, right? Now the surface of the brain is a sheet of neurons called the cortex, and then under this sheet, like imagine a car surrounded by some kind of a right. Under this sheet, there are the various structures which are called subcortical structure, which are all under this cortex. So basal ganglia is like a subcortical structure, a subcortical circuit, which consists of several of these modules. We call them nuclei. And these nuclei have some different names. You don't have to mug it up. You can call them XYZ if you like. Right. So the basal ganglia gets inputs from cortex and outputs go back to cortex. So it's like a side loop, right, from the cortex. And within that, you have all these different boxes, different blocks. Input from the cortex goes to this part called striatum. Output goes out from these two regions, GPI and SNR, and goes back to the cortex. Within this, there are two pathways. One directly goes from striatum to GPI. Another takes a longer route from striatum, GPE, STN, and GPI. This is called so the short one is called the direct pathway for obvious reasons. The longer one is called the indirect pathway, also for obvious reasons. Now, there's this other small module where you have cells that release a special chemical called dopamine. And for some reason, we don't know, and that's called idiopathic in medicine, right? The cells here start dying. And because of that, you see symptoms in pretty much everything that brain does. Whatever brain does can be grouped into 4 domains: sensory motor function, cognitive function, affective function or emotional function or autonomic function. Because of loss of cells in this tiny structure, which has only few lakh neurons, which is nothing compared to the whole brain, you have problems in all the four domains. So if you look at most visible problems, they are called cardinal symptoms. They are in the motor domain. They have tremor, they have rigid joints, right? They have bradykinesia, they move slowly. They have postural abnormalities, they walk with a stoop, right? And they have balance problems and so on and so forth. So within motor alone, there are so many subcategories, all of them can be affected. So on the right, you see handwriting written by a PD patient compared to a normal healthy person in Tamil. It says Sri Ramajayam, right? You see the PD writing is very small. It's called micrographia. So if you look at the textbook of Candle and Schwartz or any other textbook on neurology, read about basal ganglia, they'll talk about these two pathways, and the direct pathway, if it is activated, that will facilitate movement. So basal ganglia acts like a gate onto motor apparatus. Unless this gate is open, you cannot move your hand. So if you activate your direct pathway, that will open the gate, you can move your limbs. If you activate the indirect pathway, that will block the gate, so you cannot move. Now, this SNC, substantia nigra pars compacta, it releases a chemical, which releases chemical into the input port of the basal ganglia. There's a lot of that chemical that is released. Then the signal coming from the cortex goes straight through the direct pathway. If chemical release is less, which happens in disease condition, because dopamine cells are dying, the lesser dopamine release, then that will activate the indirect pathway, that will close the gate. You have difficulty in movement. So it's a very simplistic story that the textbook tells you. Right, so we said, this story is not sufficient. We need to expand this story, right? And so the direct pathway is called the go pathway because it will make you go. Indirect pathway is called the no-go pathway because it make you not go. So we said you need to have a third thing which we call explore or exploration. It's a long story. I don't think I'll have time for explaining all that. But so with this expansion of the picture, you were able to model wide variety of motor functions and cognitive functions that are associated with basal ganglia. We published all this work in a book form, which was released published by Springer and published a few years ago. Subsequently, another PhD student of mine, this is a work of many PhD students like Pragati and Alekya, Vignesh and Gangadhar. They have done masters or PhD. So more recently, Vignan has taken up. So until then, the question we asked is, okay, these cells are dying. We don't know why, but why are you seeing all these symptoms? What's the cause and effect connection? Next, we asked, why are these cells dying in the first place? What is wrong with them? Why are they vulnerable? So we found already a few labs have proposed that these cells are dying because of metabolic deficiency. For some reason, energy is not getting to these cells. Because energy delivery to the tissues, right? All energy is coming from the blood vessels, from the vascular system. But a huge cellular and molecular machinery that takes energy, like glucose and oxygen, from the blood vessels to cells. And unlike in other tissues where it's like energy is released by the vessels and cells pick it up, there's no problem. With brain, because brain works under very stringent conditions, and there is an associative network which takes energy from the blood vessels and passes it on the neurons. There's a huge system is there just to provide energy to neurons. Any failures in this system will create problems, and especially the cells like dopamine cells, which come in a category of diffuse projection system. These are small clusters of cells projecting to wide number of targets. Right, they're under a huge metabolic stress because they're working very hard compared to a cortical neuron. So it's very natural that under metabolic stress, and therefore they die. In fact, if they don't die in big numbers in everyone is not Parkinson's patient, then actually it's surprising. Because it's a very natural thing, you expect it to happen. Okay, so with that perspective of why these cells are dying, that will open up different lines of treatment. But then again, it's a lot of work to connect theory to treatment. So our long-term vision is to put this whole treatment of Parkinson's on a quantitative and model-based or a digital twin-based footing. So where when the patient comes, you take clinical data from the patient, quantitative data like their speech data, handwriting data, gait data. All this you can take from a smartphone. You don't need very fancy equipment. Then that data you plug into a computational model. That will set down some metaparameters of the model. And these metaparameters have a biological significance. They are parameters which represent norepinephrine levels, dopamine levels, serotonin levels, and so on. So with that kind of a biologically plausible model, right, then that model becomes a digital twin. And whatever treatment you want to give it onto the model first. and only when the model it successfully approves that, you give it to the patient. I mean, that's a long term vision, and we have a long way to go to realize that. Another area where we been working on in the lab for the last 6-7 years is modeling hippocampal spatial cells. Hippocampus in the brain, you might have seen the movie Gajni, right? This guy has memory loss and keeps writing on notebook and all. Hippocampus has another kind of fame. It is called the GPS of the brain. This is a part of the brain which lets you find your way around in space, right? So some fundamental breakthroughs that occurred in this field is way back in the 70s. John O'Keefe and another colleague of his, they found this special kind of cells in hippocampus called place cells. So these cells fire whenever the animal or the person is in certain part of the space. Let me see this video. This is from some experimental lab. It's not our lab. So see that rat's brain, right? The electrodes stuck inside hippocampus, actually in a single neuron inside the CA1 part of hippocampus, and that red dot basically indicates that the neuron has fired at that time. So whenever the rat goes to that part of the box, that neuron is firing. Right. So what that means is that neuron is indicating that the rat is in that location. Neuron represent that location like a pin code for a region, for a zone. So this cell is called a place cell because it indicates certain place. Similarly, in 2005, another Norwegian couple, Edward Moser and May-Britt Moser, they found a different kind of cells. These cells fire not at one location but an array of locations, and all these locations form a very nice periodic spatial grid, and often that grid is in the form of a hexagonal grid, which is very weird because brain is such a messy, disorderly structure. It's not like a crystal where things are very orderly. How do you get that kind of a strange order out of such a messy network? Right? It was very intriguing, and these cells were called grid cells. So these two groups were given Nobel Prize for medicine and physiology in 2014. Since then, this area became very popular. There's a lot of glamour around hippocampus and spatial navigation. So we began modeling this about 6-7 years ago. We created a bunch of models. We could explain, like these are unified models to explain wide variety of spatial cells, place cells, grid cells, border cells, corner cells, all sorts, all in single unified model. So initially we did with 2D navigation because a lot of studies are from 2 dimensions, rats running on a plane. Then we also extended the model to 3D. So for example, bats, although they fly, they are not birds, they are mammals, but they have a hippocampus. So we got this data from Michael Yartsev of UC Berkeley, and we could again show place cells. The model very easily shows place cells in 3 dimensions. And not only that, model predicted new kinds of cells, which we call plane cell. A plane cell, hypothetically, is something that fires whenever the animal crosses a certain plane in 3 dimensions. Model also suggested a third category of cell, which we named stack cell. This cell fires whenever the animal crosses a set of planes in 3 dimensions. So a stack of planes. So we called it a stack cell. So my student Karthik, after finishing his PhD with me, he went and joined Yartsev's lab in Berkeley. So there he dug up all data and actually found plane cells, which we predicted. But there's no evidence of stack cell because maybe it's just a theoretical thing, or we have to dig deeper to really look for. Maybe we can search for data from birds, right? And so look for stack cells. So that's what I'm saying is that's the kind of predictions that theory can make. And these models are very simple. You would be shocked to see how such simple models can explain so much information, so many experiments from spatial navigation literature in hippocampus. So we published a lot of stuff on that. And most latest one was by Azra, my student, which is published in Journal Hippocampus. Okay, so we're also doing a large project on stroke rehabilitation, which combines computation modeling, neuroimaging, and gaming. So we developed a game system which is now under clinical trials at both Suchitra and IMHANS. And we also did a bunch of computation modeling and published one in Nature Scientific Reports. I'll skip some of this stuff. Okay, a lot of excitement in the lab now is in this area of neural oscillations because we keep talking about brain theory. Now, so a lot of in AI, about deep networks and convolutional networks and all that. They are also neural networks, but brain doesn't look anything like that. Right? These neural networks can learn the behavioral aspects. They can recognize patterns just like humans, and they can even beat humans. But when you actually probe the neurons in the network, their activity doesn't look anything like the real neurons in the brain. They're very different. Because brain is full of oscillation. Brain is a very dynamic environment. Whereas in a deep network, there are oscillations. There are no oscillations in deep network. So you need to construct networks of oscillators. So we began that effort about again 5-6 years ago. We started with a nonlinear oscillator called Hopf oscillator. And since you are engineers, I can tell you this. We found that when you describe these dynamics in the complex variable domain, we all know what complex numbers are, right? X plus IY, right? So there we have some very new kind of modeling frameworks that are possible. With that, we are able to explain very complicated EEG data. So with this, we are able to create large-scale models of brain dynamics and capture data from EEG, high-dimensional EEG data or fMRI and so on. We also just recently created what we call deep oscillatory neural network. You have a deep neural network which have sigmoidal neurons, but imagine replace all your sigmoidal neurons with oscillators. And that network has a chance of looking more like real brain dynamics. Right. So anyway, I can come back and talk more about it because that itself is a big topic. We have done some work on vision, modeling various aspects of visual function, and also another area where we've been working for the last 10, 13 years is neurovascular coupling. How do neurons and blood vessels talk to each other? This is again a huge field, a very complicated field because everything in the brain is very complicated. But if you let us pose this question as an engineer would, right? Neurons are working very hard. They're firing away, spending a lot of energy. They need energy. Where does energy come from? The blood vessels. Now think of it like this. I have a bunch of neurons, I have blood vessels, and neurons are saying, oh, we're working very hard, we're hungry, give us energy, sending out these signals, like vasodilatory signals. Then vessels dilate and release glucose and oxygen. Now think of the situation. I have this neuron A here, which is working very hard. It needs a lot of energy. I have neuron B here, which is a lazy bum, right? Doesn't work very hard. So A should get more energy than B. Okay. Suppose you have a separate hotline from every vessel to every neuron, then life is simple. When a given neuron is hungry, it will only dilate the nearby vessel, right? And then that energy will only come to that neuron. But that's not how it is. And vessel dilates, whatever it's releasing will go to lots of neurons in the neighborhood. So how do you make sure that only hardworking neurons get more and lazy fellows get less? If you don't optimize the energy release like that, it will be very inefficient way of energy delivery. That brain won't survive because you are wasting energy. You have no discrimination, you're just freely giving energy to everybody. So what kind of a network will give you that kind of optimal and calibrated delivery of energy to the neurons? Okay, now this is a math problem. This is no more biology, right? And once you do that, we found that you end up with a network structure which is just associative memory. The neural network we study such networks all the time. It's not a new problem. And then, so if that is the case, then there must be learning going on in the vascular network. Vessels should be also learning the way neurons are learning, right? You should talk about vascular plasticity and so on and so forth. So people have, I'll skip a lot of these modeling details, but people have, big people like Majestati in Switzerland, they talked about metabolic plasticity, but they have no clue how. What is the substrates of that? So we proposed a model just recently, it was published in, again, Nature and Scientific Reports. We proposed something called artificial neurovascular networks. So in a neural network, we all know you can train the network using backpropagation and all that stuff. But imagine a neural network in which the neurons need energy for them to fire, right? Where does the energy come from? Imagine some kind of a vascular network which is feeding energy into the neurons. Now, vascular network has only so much energy to go around, because energy is always a limited resource. Now you have to decide which neuron should be given how much energy, so that it will only get proportional amount of energy. How do you decide that? So we just propose that whatever error you are backpropagating to train all the neural network and its connections has to be backpropagated further into the vascular network. And you train the vascular network. That means your microvessels, arterioles will be getting trained, right? So when we proposed that, and it was published, and a lot of interesting consequences came out of that. So in this line of thinking, we proposed almost 10 years ago, 2009 paper, that just like neurons in the visual system respond to patterns, respond to oriented bars and all that, the arterioles in the visual system also should be responding to oriented bars. Right? Whenever you present a bar of 60 degrees, some small microvessel should dilate just in response to that. So tuned to that. We proposed this in 2009 paper. And 2016 in Nature paper, people have demonstrated that. Right? Prakash Kara and O'Reilly and all this, O'Heron and these colleagues. So more recently, I contacted them, we collaborated and published another paper in European Journal of Neuroscience. So point is, when you take a very simple fundamental engineering approach to neural phenomena, things fall in place. You can explain things. You can explain a lot of things, right? Because you cannot avoid physics. Brain cannot run away from physics. It's a physical object, right? And all the complexity seems to be more apparent at the base of it all. It runs on very fundamental, simple principles. Again and again, we are seeing evidence of that. Okay, so what is our long-term goal is to create an oscillator theory of the brain. So oscillations are so fundamental. In physics, everywhere you have oscillations. Optics is full of oscillations. Electromagnetism full of oscillations. Physics also, people try to construct everything using oscillations. Quantum mechanics is all full of oscillations. Right? So why not create a beautiful brain theory in terms of oscillations? So that's the long-term goal. Again, I'm overestimating the amount of time I have to retirement. And recently, my friend said there's no retirement these days. You should keep on working for 20 years. Look at Noam Chomsky, is still active. Yeah, right. Thank you. I mean, you just spoiled my retirement period, right? So, yeah, like I said, this is my long-term dream to put this whole neuro treatment on a solid quantitative footing, model-based footing. And in basic science terms, work out a whole oscillator theory of brain function and embody all this in a single model of like a whole brain model. If you are able to do that and also even realize that whole brain in a hardware, neural hardware, we began discussion with circuits people in my institute. Then on the medical side, you can develop, I think, better treatments for stroke or Parkinson's, Alzheimer's. At least get more insight into what's happening in this disease. On engineering side, you can take this model, put in a motherboard, right? Put it on a drone, put it on in a driverless car or a submersible, right? Let it run a factory. I mean, suppose you have some strange nuclear plant far from human civilization. Who will go there? You put this kind of a brain there. It will run the plant, right? So those kinds of things. My dream is to create centers of neuroscience, right? Research centers. The very focused model like this. The core activity will be model building, theory building. Around that, you'll have a network of experimentalists, clinicians, right, approaching this one disease from various points of view using various tools. And all these people will work with the modeler, and modeler will have to explain all this data. We cannot exclude anything. It should be an integral model. Every aspect must be explained. And once you figure out that the disease is so completely, so integrally, then you create startups out of it, create tools and solutions and so on and so forth. So my lab was featured in this book called India Science Geniuses. My students say it's very embarrassing. How could you allow this? Right. Okay, so anyway, so my collaborators, about national, international, and we have some industry partners who have been supporting us. And some of my alumni, some of them have come back. Pragati and Vignesh have come back. Pragati is at IIT Kanpur, Vignesh is at IIT Jodhpur. And this is a picture of lab. Jai Hind. Thank you. If you have any questions, I can take them. Otherwise, yeah. So can I go home? Yeah, sorry. Go ahead. What cells? Yeah.
To your model, what you add with input of energy to the neurons.
Yeah.
You spoke about that.
Yeah.
Could you conclude from that? Is that the reason for the lack of energy?
No, so a good question. I'll tell you what we have found, but that may not be the complete answer. See, the cells are dying because of metabolic deficiency, and why is there deficiency? For multiple reasons. So first of all, these cells, like I said, they are like diffuse projection system. The same small number of cells send wires out to many distant targets. And thing is, the longer wires are always axons, and axons are more energy intensive because axons have this myelin sheath, and they need mechanisms for recharging the signal as the signal propagates. So the energy expenditure is a lot more for axon propagation, especially when the single cell has to send out to many targets. So they end up more metabolic stress. These calculations have been done, for example, by Paul Bolam group in Oxford. That's at cell level. Now, if you look at systems level, more at network level, take, for example, how these cells interact with other targets, even in basal ganglia. Take how substance nigra talks to the subthalamic nucleus, another major structure in basal ganglia. So signals from substance nigra go to subthalamic nucleus, and feedback from subthalamic nucleus also comes back to this thing. So what happens is, suppose for whatever reason, general wear and tear, a few SNC cells die. So to that extent, dopamine release to STN goes down a little bit. And the effect of the reduced dopamine into STN is to make STN overactive. It will get disinhibited because it will act effectively it will increase effectively the connection strength among the STN neurons. They become overactive. So the STN neurons which are overactive, when they feed back into SNC, they're firing them with even stronger signal. So they're under higher metabolic stress. They're greater glutamate release into SNC. They're under even higher metabolic stress. They also undergo what is called glutamate toxicity. So therefore they die even more. So there's then even lesser dopamine. So even more activation of STN. So it gets into a positive feedback loop. So any loss of cells because of general wear and tear, right? If it goes beyond a threshold, this positive feedback loop kicks in, and the cells keep on dying continuously. This is neurodegeneration, and the presence of these positive feedback loops, right, seems to be explaining neurodegeneration very well. So it's all set. I mean, it's surprising that it doesn't happen to everybody so dramatically. We all lose dopamine cells. It is just that may not be in such a great extent that you see in a PD patient. It's a question of threshold. Yeah. Thank you. Sorry? Yeah. 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 Correct. Yeah. 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 Correct. Correct. You said it right. That's why in my picture also. No. Correct. So no, even if you add one more layer, that doesn't change the theory at all. No, integral importance. Everything in its place. Huh. Glial cell network might be better in that. Yes, very likely. Yes. Yes. In fact, you might have heard of Douglas Fields, right? He's written a beautiful book. It says everything is glial. All diseases have underlying glial involvement. Okay. So, yeah. So, and in fact, he calls this the other brain, right? In fact, I wanted to write another book involving vascular network. I want to call it yet another brain. Because these three networks are working in tandem. We give too much credit to neurons, but actually all these three systems are working in tandem, right? And then you need to have a more integral view of brain function. Otherwise, we'll make the vessels look like some kind of guys who supply chai. It's not like that. I mean, they're profoundly involved. There must be a lot of information processing going on the vascular side also. They could be having memory, they could be having maps and so on and so forth. But it's a lot of work. Nobody even talks about it. Yes. Thank you. Thank you. Any other questions?
Good afternoon, sir. I might sound a bit arrogant, but
Please.
I have opinion about the similar level study done biology that you stated. Like, based on my knowledge, which might not be much subjective, but usually similar level study for any disease is done in biology because we want to observe any small chances that it might be toxic in some other thing. For example, the lithium treatment used that the example was said. The lithium might be useful for that problem, but it might be dangerous for some other organ, might infiltrate something and cause other disease. So to not compromise with any diseases, they use further affect this. That's my opinion. I want to ask this one question. What might be the problems that we might face if we want to do something like a human genome project? Like in human genome project, it was done very labs across the world, analyzing this different data from the entire world and assembling it to one platform. Similarly, if we want to make an MR plate, like different functions, each done in different labs, different sets of equipment to be prepared. Like the process of fine grain to be done in one lab, the temporal functions to be done in another lab, and assembling this in one place, correcting any others, and finally getting the plate is not possible.
So that's what people are attempting now, right? Also, we are not, when they do this, they are not doing temporal lobe function. They are not doing temporal lobe structure. They're assembling the structural model of the brain, which I don't know, for me, if you have enough resources and if you fine tune these algorithms for reconstructing the 3D structure, it must be quite doable. It's a lot of effort, but it should be quite doable. I'm not talking about that problem at all. For me, it's a non-problem. That's what I'm trying to say, right? My goal is something else. So unless you solve that, even if you with 1.2 billion euros, right, you work out the complete human brain, you will not be inch closer to solving a problem like Parkinson's. So why do you worry about that problem or its solution? I don't wait for that solution with excitement.
And sir,
I don't know. Did I answer your question?
but the question I asked is relevant to what you are doing.
Yes.
And small suggestion I would give, sir, is it possible to increase the study of cellular level, like cell microenvironment studies, so that you can get more data about neurons and their functions better?
But that's happening all over the world. But again, like I said, my goal is different. I'm trying to find which part is getting neglected, and I'm harping on. That's all I'm saying. Thank you.
Good morning, sir. Sir, in this energy feedback mechanism, is it possible to stop that energy passing from data sets to neurons? Because in glioblastoma cancer, whereas astrocytes divide continuously, so for the cell division we need ATP. Can we stop that ATP production from red vessels to DSS so that we can control glioblastoma?
It's a very deep cell biology question. I have no idea. Can you please? Do you have any idea what he's talking about? Please ask Dr. Anita. I'm not the right person.
In glioblastoma cancer, the astrocytes divide continuously right now. So is it possible to stop that energy feedback mechanism so that the cells can stop dividing?
No. Actually, if you stop, no, if you stop the ATP coming from astrocytes,
no, from the blood vessels to the astrocytes.
What is coming to blood vessels is glucose, not ATP. So
we are getting ATP from glucose.
Yeah, but astrocytes convert it into lactate. Lactate goes to neurons. Neurons convert it into pyruvate and ATP. So neurons make their own ATP out of this stuff coming from coming.
We are finding for biomarkers. Can we stop that energy releasing enzymes?
That will kill neurons. So what is the point? What did he say?
Can I stop you and not?
Yeah. Oh, yeah.
That's try and find the blood quite a wide trying to target just to be precisely done. But they're trying to use that same context. So in the yes, accurate target only the I don't know how
No, that's correct. Because if you just, in order to throwing the baby with the bathwater kind of thing, right? And just to kill the tumor cells, if you kill the neurons, then you're in trouble. Yeah.
Thank you.
Yeah, Shyam, please go.
Any comment?
Go ahead.
Complete cycle about the loops that exists in the model.
Which one? The,
Neuron.
no, I didn't want to get into all that. I mean, like,
How would that
so because somebody said, oh, this is all engineering, where is biology in this? Then we said, okay, this is biology. And build this whole model with 89 equations for 3 cells. And people are not as happy. Oh, this is not still not biology. Put more equations. And we read 170 equations for an SNC cell. And there's no end to it. But anyway, we'll cater to pander to the gallery. Uh, yeah.
So,
Yeah.
I'm just writing student who is in mind. So, sir, what you were saying about this approach, like a holistic approach towards biology. So, like, it is kind of a new thing for me, like, which I just came across, and I was just wondering how a medical student can progress in certain direction to develop such a process, like going from from first year we study biochemistry and then after that everything. So as you said, the main crux is like finding something at the molecular level on it, but see that we are not able to do anything about that because we lack the holistic approach. So what should we do at holistic?
Great question. In fact, Professor Rao was just saying that there is a trend to bringing together engineering and medical curricula. In future, it will happen more and more. In IIT, we start this new department where the students take engineering and math, physics courses in IIT and go to a medical school and learn medicine along with medical, just like whatever they learn, these guys also will learn. Now, as if you're already a medico, what you can do is don't leave your high school physics, your plus 2 intermediate physics and maths. There is a lot of material which can teach you physiology from a physics-based point of view. Like Guyton's textbook itself is a great example. In medicine, you have Guyton and Ganong. Ganong is all rut, it's just mud, mud, mud. And Guyton is all about underlying physics. It so beautifully explains physical concept without using equations. There's a lot of strong physical flavor to the way he describes it. Very beautiful. It's not easy to do that. But that is completely thrown out in, I mean, I don't think, my understanding is you don't really take it seriously in medical curriculum. Go back to that. In fact, if you are interested, I always say, generally, general advice students, don't wait for your teachers to tell you anything. You take up books and start reading all by yourself. If you are very keen on understanding, it's like, somebody said, if I starve you, will you be okay? If you are starved of knowledge, you will figure out on your own. Just go ahead and keep reading, reading, reading. Right? And come to your own synthesis, make your own conclusions. And if you are wrong, this system will tell you very soon that you are wrong. Right? So don't wait for some curriculum and all that. Okay, if you have workshop like this, you can always attend. That will enrich your this thing. But take up independent individual study. You will go very far. There's a lot of good material out there. Who is now converted? Thank you. Any other questions? I'm sure you're all hungry, right? I mean, you're not hungry. Yeah.
Teacher this. So I see that the transition of the biology or master of biology and engineering is happening at some institute. How can we bring down this to a teacher? As a teacher, what do you see, foresee? What kind of training should we take for teachers first to have this master? It's mostly isolated silos.
Yeah.
They literally have it. Teach the circuit. He's only getting the circuit only on radio. First time I'm seeing a radio being compared with
brain.
So it is very clear for a student of first year also. So as a teacher, what do you think? How should we train our teachers?
Excellent question. This is a question that all entire academic world is dealing with. Now, I think it's easier done in an engineering institute than a medical institute because an engineer, because with the tools of maths and physics, it's easier to understand biology. The reverse direction, especially if you are in medicine for 10, 20 years and you go back to physics and math, is very hard. But if you have math and physics background, if biology is presented in a fashion, it can be done that you formulate it in physics term, it will be easier to understand. So suppose you are in a biotech department or something like that. You have students learn some math and physics in the beginning, right? I can suggest a bunch of books. These are not textbooks. They're popular science books written by experts in the field who have done some very unusual work for a whole lifetime. So say 20 years of research is compressed into one book. For example, this Douglas Field's book on glial cells is one such book. I can give any number of books like that will completely shape the careers and minds of the students. You read 2-3 such books, it will open up worlds for you. I'll give you a couple of examples. There's a book called Dynamic Patterns by J.A. Scott Kelso. This guy is a dynamical systems guy, physics and maths person. He has taken a lot of phenomena in motor function, in biological motion, and is able to explain all those phenomena using a handful of mathematical concepts. So beautifully written. During my PhD days, I literally did a parayana of this book over and over and over. It's so beautiful. Take, for example, the book by uh, Robert Becker called it's called the body electric. Right? It talks about electrical phenomena in the body. Now that's a proper engineering topic. Right? Body is full of electricity, but in medicine you never learn that. Right? You never bother about that. So even regeneration, which is such a hard problem, this guy discovered how DC currents can change tissue regeneration. And so if you read that kind of books, right, they'll completely change your perspective and you'll be inspired about it. After that, you can go take courses, go to workshops, and get into some internship and so on. But everything will start with inspiration. You should be fired up about, oh, I love this book so much. I love this field so much. I want to get into it, do more seriously. That can come with a handful of books. I mean, I can suggest a bunch of titles you order for your library. Students can read them on their own, or the teacher can encourage them to read. Beyond that, you don't even need much spoon feeding. They're very nicely written books. I mean, lots of them, like Dennis Noble's book on music of life, his discoveries on electrophysiology of cardiacs, tissue. I mean, this is like a whole world of such literature. Yeah, I'll come. No problem.
There will be something for every part of the exam.
No. No, we always.
One course, refreshing course, which has to be
No, sorry. In India, unfortunately, for everything, our solution is make up a rule. Right? It's a very Indian thing. Make a rule. And already we are such a enslaved nation. Why enslave ourselves even more? Free up. Right? It will happen. Why not? Individuals will make the change. Let them be inspired about something. They'll bring about a change. No need for more rules. You have already too much rules. Okay. Yeah.
Sir, maybe I want to ask a question which is slightly off the question is we know from several evidence that emotion, the state of emotion, implicit as well as through explicit results affect a lot of neuronal behavior and the brain function. And you look into this aspect in any of your model and if you can just glimpse of it.
Great question. Because emotion is a very deep topic. It's an emotional topic. So emotion in the brain, it's subserved by a system called limbic system. Right? And limbic system is a hodgepodge of actually many brain structures. And there's a lot of controversy about what exactly is the limbic system. So you have medial cortical areas, and then you have mammillary bodies, and hypothalamus, hippocampus. So there are two pillars of emotion, right? The pain and pleasure. Everything is a mixture of these two. Now, when it comes to pain, it is amygdala, and pleasure, it is dopamine system, reward system, all that. Around these fundamentals, I have a dream of creating a theory of emotions based on a lot of stuff that is available. I mean, Joseph Leduc has done a lot of work and so on. And you might have heard of this Plutchik's color charts. A lot of emotions are put in a nice framework of colors, the analogy between color and emotion. So if you look at literature, there are pointers to a comprehensive theory of emotion, but haven't seen it actually worked out and applied to real emotions and so on. So we have proper theory of emotions and also mood disorders. So, example, mood disorder, we have published some papers on, one paper on bipolar disorder. We explain why there is oscillation, and So we can even think of some ways to treatment with that model, but we haven't done that. It can be done, but yeah, we haven't done it. So I think in my lab, what's happening is we are at a stage where we can quickly do a lot of things, provided there are people. With this 20 years of experience, we can, if there is a whole army of people, we can work out, somatosensory system, auditory system, and I don't know, cerebral, with Sham's help, we can do that. But provided I need a whole army. Like, I mean, the 30 PhD students and 20 postdocs, that's the kind of thing. Easily we can do that.
Have a bunch of students.
Yeah, definitely, I would love it. I mean, especially if KLU faculty, if they're interested, and you put a couple of students, each of you, and then we can do that. We can. Fine. It doesn't matter anywhere. Anywhere on planet Earth is okay for me. Thank you very much.
Hello, sir.
Yeah.
Sahitya.
Right.
In our brain, the most complex part is, or the complex functionality is imagination.
Hmm.
And the idea is very fascinating to develop a model of a brain and how we're going to tackle this imagination concept, because imagination is something that requires all the parts of the brain to be active. For example, all sensors activation, hippocampus, and everything is going to work when we imagine certain aspect. So how can we differentiate? How can we function? How can we function of imagination? It's a broad topic that scientists got into much deeper. So how we are going to tackle this?
Yeah, so great question. I think when it comes to these kind of topics, I find neuroscience is slightly schizophrenic, because on one side you have this rigorous standard of experimental neurobiology, where whatever you talk about has to be measured and observable. Now, what is imagination? I cannot observe it, so just throw it out. I cannot talk about it. Right? That is a hardcore neuroscience approach. But then in psychology, you can't do that. People have minds in psychology. You have emotions. You have to deal with it. You have to talk about it. So, as a neuroscientist modeler, I very hard to do. But what we have done is take the problem of free will. Huge debate. For example, Marvin Minsky says free will is an illusion. Right? So I would say Marvin Minsky doesn't have free will. That's about it. Right? Don't speak for me. I have free will. Okay. Thank you. So we propose a theory of free will. How does will act? For example, voluntary movement and sensory driven movement are not the same even neurobiologically. For example, in voluntary movement, the SMA gets activated first, very slowly. You have this Barrett short potential, all that. It builds up over hundreds of milliseconds, like a full 1 second, and then slowly movement onset occurs, right? And we propose that this happens because of the loop of cortico-basal interactions, and we said there is a free will signal, which is a very weak signal, which needs amplification. Amplification occurs through a phenomenon called stochastic resonance, which is our theory, which occurs in this loop, and the signal is amplified slowly over several cycles of this, and only then this thing output, you see the motor output. So in our theory, we didn't hold back to propose that there is a will signal. We are not saying there is no free will. Will is a delusion and all that. There is a real will. When it's a weak signal, it needs amplification. If you extend this line of thinking more boldly, then we have to accept that something called consciousness, and it has real physical effects on the brain. Right? It will lead to very quickly hardcore dualism. I mean, unabashed dualism. So on sensory side, my consciousness actually feeling the electrical activity patterns of the brain and sensing it and experiencing things on the input side. On the output side, the same electrical fields are modulated by action of my consciousness, my free will, and I produce motor outputs. I can wave my hands and talk and so on and so forth. I mean, this is a complete unabashed dualism. Without that, we'll be just going in circles talking nonsense. I mean, let us be open about it and invoke something like that. The only thing is, let us calculate it. So be quantitative about it. When it comes to imagination in simple modern terms is just as you wave your thoughts. That's imagination, right? And that can be completely, see, the cortex hippocampal loop is an inner loop. The cortex, motor cortex, and limbs, that's the outer loop. So there is a signal that goes from motor cortex where you produce a visible motor output. Imagine a signal going through just prefrontal hippocampus back to prefrontal and sensory area and all that. That activity is not manifest outside. That is imagination, or that you can call it memory recall. So, if you want a good theory of imagination, it should be you should seek somewhere there. But like I said, if you want to work it out, and we are willing to work with you, and you build that theory with us.
Small cross comparison study idea where so it's a theory that cross comparison study already covered rankings who are going to be perception. For example, who are starting to understand a person after the age spectrum of 14. So those kind of people start taking interaction between the and then they can create an imagination world as first one they can create. So we can cross compare these people with people who have imagination. It's a recent study that we found. So it's a study where people cannot imagine at all. And we can also take these people with a common person and we can understand what are the networks or the areas that can isolate this specific thing and we can.
Thank you. I mean, we can correspond and thank you. That's it, right? Thank you very much and happy lunch.
That's a wonderful information and a very enlightening information and valuable inputs on deep reforms in brain theory and profound transformation in understanding neurological disorders, nature of biology, bipolar disorders, multifactorial disorders, and the Mesobrain project by our keynote speaker, Dr. Srinivas Chakravarti sir. Sir, thank you so much for enlightening with a lot of information to our students as well as participants. Thank you so much. Ladies and gentlemen and dear participants, let's all break for lunch in SAC Hall. I request all the esteemed guests and registered participants to have sumptuous lunch and get back to this hall by 2 p.m. And I request all the volunteers to guide the participants the venue SAC Hall, and the guests will be accompanied by our KL authorities. Let's all break for lunch. Thank you so much. The registered participants, kindly make a note towards your right. Towards your right, the volunteers will be guiding. Yes, towards your right. Take towards your right, and the volunteers would be helping you to guide A very good afternoon to one and all. I request all the participants to be seated as early as possible. As it is 2:15 p.m., we are going to start the session very soon. Yes, we are going to have a wonderful lecture session by Professor T.S.S. Rao sir. So I request all the participants to be seated sooner, fast. Once again, a very good afternoon to one and all, and welcome back to the day 1 of 5-day workshop post-lunch session. Before going to start the session, let me humbly invite the KL authorities, our Pro-Chancellor sir, Professor K.S. Jagannath Rao sir, Professor Buchnaidu sir, Director Research Life Sciences, Professor Chakravarti sir, Principal College of Pharmacy, Professor Giridhar sir, Department of Biotechnology, Associate Professor and Associate Dean, Professor Vasuja Devi Madam, Department of ECE, onto the dais. I take it a great privilege to invite and delighted to invite and honor Professor T. Satyanarayana Rao sir from JSS Medical College, Mysore. And may I request Professor T. Satyanarayana Rao garu to come on to the dais and receive the prestigious award, C.V. Raman Award. Please, sir. We are very happy and glad to honor Professor T. Satyanarayana Rao sir from JSS Medical College, Mysore, for his outstanding contribution in bipolar disorders and sexual medicine. KL University feels deeply honored to recognize the outstanding leaders in multidisciplinary brain research, such as Professor Rao, for his outstanding services in clinician in psychiatry and well known internationally for his research on neurological disorders and sexual medicine. Dr. Rao has won many outstanding honors and awards, and he is in the editorial board of n number of journals. We proudly honored to honor Professor T.S.S. Rao from JSS Medical College, Mysore. Thank you so much, sir. On behalf of CAL management, we are very much privileged and honored to honor you with Sir C.V. Raman Award. Thank you so much, sir. And dear students and participants, as it is the time, we are going to have a wonderful lecture session by Professor T.S.S. Rao sir. Over to Professor Rao sir. Thank you, sir.
Okay.
We'll start. Good afternoon, everybody. Good afternoon. Okay, good. At the outset, let me place on record my gratitude and thanks for KL University for this wonderful award what you have given, hospitality what you have extended, and the goodwill to carry back home. I am really grateful to you for all. My association with Dr. Jagannath Rao spans almost 3 decades plus. I joined JSS Medical College in 1987, maybe about 5 or 6 years later, because they were trying to do some neuropsychiatry research in the basic sciences. A casual meeting turned out to be one of the wonderful journey of life. And I am really grateful for all the activity what we could carry out. And how many of you know Dr. Jagannath Rao in detail? I don't know. But let me tell you, has been an epitome of energy. There are very few administrators who we have seen who can deal with life in such a wonderful way, take people along, a leader and a team man. And to be frank with you, as we medical people hardly had any basic knowledge about whole lot of things what you people do. Make us understand and carry forward. If KL University is having Dr. Jagannath Rao, that means they are really lucky. This much what I can definitely say at this time. I was told by many people that he has told so many good things about me. It only shows that he likes me to some extent, and that is the one which has made him talk like that. And when I was talking to him, he is still looking very happy. A married man looking very happy means there is almost always a little doubt. We say happily married people are those where I am here and wife is somewhere else. No, you are the one of the most critical person in our life who assesses us is actually wife. And let me tell you, before I begin, I had developed COVID. My wife developed COVID. Both of us were kept in the same room. The life taught me that to stay with your own wife in the same room for 7 days is one of the most difficult job on the earth. At the end of the 7th day, she was telling all like that. I was very happy that she will come out with some positive things. Her comment was, how a single person can do so many mistakes. This was the comment. So this is what actually, so he is a very happy person because wife is at USA and he is going to live long, so long actually she stays at USA for a longer time. There's one aspect. My field of expertise is actually currently in different area. We talk about sexual medicine in great detail and we are working on this particular field for a pretty length of time. Sex is almost always an interesting area. See, for example, Dr. Srinivasan was talking about the whole range of things which are actually important. But if you try to look at the center for the sex, center for alcohol, center for opioids, center for anything pleasurable, almost all are the same area what actually they operate. You talk about septal nuclei, you talk about nucleus accumbens and whole lot of such these things. That means ultimately, whether we like it or not, we have to merge at some particular point to understand. Many of the people who land up with a whole range of drug problems and quite a few psychiatric disorders, in fact, the whole story is related to the fact that, in fact, in what way actually something is actually operating. Still, we are far, far away from making a clear sense out of it. But psychiatry, social sciences, psychology tells us why actually something happens. See, somebody is dependent on alcohol. In fact, how a woman interprets and how a man interprets. We had one program. An alcoholic was supposed to come and tell us about his problem, and wife is supposed to tell her problem. He came on the stage and told, Sir, I am not like other alcoholics. I am a very happy in this thing and I don't create trouble to others. I take drinks and I come and sleep. When wife's turn came, she was there on the stage and she was telling, sir, what to do with a man who comes and chuma sleeps? No, you got the point. So there are very many different aspects which are actually related to this. So that's what we actually try to explore. Though the topic given to me is actually bipolar, I may be talking a little here, there to just to keep you a little awake, because afternoon session, I can be dead serious and make you all sleep without conveying any particular message at all. But all said and done, that is not the purpose for which I have been called for. I believe in that particular fashion. Before that, at least 3 to 4 people asked me, are you from Andhra? Because my name is Satyanarayan Rao. I am a Marathi, born and brought up in Karnataka, studied in Tamil Nadu, look like a Malayali, and everybody confuses me for Andhra Pradesh. So I can gel very well with any place on the earth without much difficulty. There is one more point. Little funny things have been added, mainly because my mother had 4 sisters. She wanted a son and she started visiting a temple, and this particular temple was Anjaneya temple. So a lot of influence of monkeying actually has come to my personality. So be tolerant to some of the things I would be tell you. And with these few introductions, one point what was actually Dr. Srinivasan was telling, very, very far away we are. I'll tell you one real experience, then you'll understand why we are actually still very far away. My mother was RH negative. My father was RH positive. She has 4 daughters. When she developed malignancy, that time only we realized what is her blood group. A 5th born child for an RH negative mother who has not taken any immunization related to actually to counter the antibodies, what are the chances of somebody being all right? No, you got the point? When I discussed with pediatrician, they told this can happen 1 in a million. I am standing in front of you. I should have been in one of the mental retardation schools and all of that. I am standing in front of you because we really don't know what actually, how actually the God or the nature plans a lot of things. The last one, before I get into the picture, you know what was my marks in mathematics in SSLC exam? Can anyone of you guess and tell me? Huh? 60%, 100, 35 marks. Can you imagine 35 marks? I had scored 35 marks. Then to join MBBS, I had written an additional physics paper. I had written 52 plus pages without knowing what is actually physics. You got the point? The only area where you don't have to use mathematics and you can still work very well was actually sexual medicine. All our calculation is once or twice a week. No, this is the calculation. You got the point? So I don't have to struggle with mathematics. So God somehow gave me one of the options like chemistry, botany, zoology. That particular year it was introduced in the college. I am here in front of you after doing MBBS. Had I been sent to an engineering college, I would not have been doing what actually I am supposed to do. The second point is, I have this particular difficulty in understanding mathematics. Whatever way. Some of my mathematics teachers were most beautiful teachers actually. They couldn't really change me at all because simple reason, there are certain areas in our brain doesn't work. In fact, this you call it as specific learning disorders. There are some people who just cannot do. You can do extremely well in mathematics. Some people just can't do well in mathematics. There are some people do very well in some particular field. Some people can't do very well in another particular field. This is because our brain is organized in such a way that it is almost impossible for some people actually. In fact, what you are actually seeing, whom you awarded C.V. Raman, in fact, one of the great names, who is very poor in mathematics and who doesn't understand head and tail of it. Now, you got the point? So, life is actually a wonderful journey, and I'm really grateful to God for this opportunity what has been given to me. You are all welcome to our JSS Medical College. It is part of JSS Academy of Higher Education and Research. And to be frank with you, this is one of the single roof, 1,850 bedded hospital in Southeast Asia, the biggest hospital. Very beautiful hospital, and Mysore is a very nice place. Some of you want to charge your battery, you want to marry, first you must come to Mysore. Boys from Mysore are extremely good because they are very happy with one wife, one child, and one salary. Now you got the point. This is one more other thing. Not like Vijayawada, where you make a lot of money, a lot of these things and all like that. So, is a place you must all visit. I just added this diagram to bring to the focus. First time in JSS Medical College, we started Depression Brain Bank under the guidance of, in fact, Dr. J. Jagannath Rao was actually the key person involved with that. There was another Dr. Shyam Sundar, professor of anatomy, and we started collecting different brains. Most probably, in fact, one area we focused was actually bipolar disorder and depression, and who had committed suicide, harvesting the brain, processing it, keeping it, then actually trying to analyze. And I'm going to show one or two slides and areas what we work. From medical point of view, they were all actually pioneering areas. If I talk about those things now, you people are so intellectually forward and research-wise, you have moved so ahead. It may look like very, very casual or very basic type of things, but all said and done, this is actually that doesn't happen in many of the medical colleges. And he was the one of this change agent for our college. So what I'm going to talk to you, there are a few things related to what we basically call bipolar disorder. But before going to the bipolar disorder, about maybe 5 or 10 minutes, let me just move around our specialty. See, many of the times you are talking about the brain structure, function, and things like that. There is a difference between psychiatry and what we basically call neurology. One of the simplest way in a medical college, what we teach is if there is a structural damage, it belongs to neurology. If it is a functional problem, it belongs to psychiatry. But this is one of the very wide area where it is almost impossible to meet. For one of the simple reason is actually epilepsy, grouped under neurological disorders. You open any textbooks, they'll write 95% of the cases are functional problems. You got the point? It is not possible to establish any specific cause at all. So, where this particular disorder should have been, but we really don't know, because for the sake of convenience, it has been placed at some particular point. So, we'll deal with a structure, but we are trying to look at some of the areas which are actually not very much dealt in usual context. Neurologists, many of the times, they are not exposed to psychiatry. This is actually neuropsychiatry we talk about, but many of the times, I still remember I was in CMC Vellore, and one of the neurosurgeon had referred a case. We had written the notes and we had come back, and on the way I met him in the corridor. He was telling, Rao, you had seen that mentally deranged person. I told, we don't write usually any diagnosis like mentally deranged person. It carries very bad connotation and we should not write that particular way. No, you only have written. I had written MDP, manic depressive psychosis, but this neurosurgeon interprets this as mentally deranged person. So, can you imagine? We though deal with a particular organ day in, day out, and trying to decipher the minutest possible functional changes, but all said and done, we may not be aware of how actually each of these disorders work. See, somebody was asking me about, not asking me, Sahitya. She asked the question, imagination. Who is Sahitya? You are here. I was sitting in the front, I couldn't really make out. You told about imagination. Okay. You constantly imagine and you are there. We call it as schizophrenic. You got the point? So you are not in touch with reality. You are not having insight related to this particular idea. You are not able to meet ordinary demands of life. You have some delusions, hallucinations. Now you got the point? Of course, when you are trying to talk about imagination, is a very broad terminology, various ways you can talk about imagination, fantasy and all of that. You constantly, continuously stay there. In fact, that's what actually about schizophrenia. Your imagination is running riot. And this can be explained on the basis of mood. They are all grouped under mood disorders. No, you got the point? So, at what level, how you try to differentiate and what actually the individual is presenting, based on that, we try to make diagnosis. So we make diagnosis of schizophrenia. I have seen, say, for example, in Monday where I practice, 35 years, we have seen people how they actually. We have made diagnosis of schizophrenia at the end of 10th year, 15th year. I have to convert that particular thing into bipolar disorder, depression. Somebody has been seen as depression, most probably depressive stupor, various things like that. A little while later, you make a diagnosis of schizophrenia. That is because psychiatry completely or wholly to a great extent depends only on symptoms and signs. There are only two criteria for us. One is cross-sectionally what individual is presenting, and longitudinally speaking, what actually how things are going on. See, if a disorder is continuous, there is a differential diagnosis. If a disorder is episodic, in fact, this is what actually the bipolar disorder is about. Cyclically, it comes and goes. So, cross-sectional symptomatology, longitudinal course, these two will determine. And when you are actually basing your whole diagnosis on something like clinical symptoms and signs, how much time you spend, with whom you are collecting information, whether patient is able to give information, whether relatives are aware of details, and each relative, each individual is actually something totally different. One may get information adequately, someone may not get information adequately at all. See, for example, if information is given by the lady, we get lot of information. If a man, in fact, men are hardly capable of talking at all. You got the point. See, in any given 5 minutes, a man can speak only about 20 to 30 words. A girl can speak for 150 to 200 words. No, can you imagine this? This is the point of difference. You will be giving so much of information. You are talking to a person, he hardly provides any information, and that's where we can go wrong. Change in diagnosis and whole lot of such things actually comes into the picture. This is one of the very important message what we wanted to. Mental health is extremely important. I believe you are all intelligent people. See, my IQ is somewhere around 100, maybe less than that, maybe 90, and we are more than sufficient to actually to manage life because we deal with limbic system to a great extent and not highly intellectual like you people. To your IQ, you may not be able to match. But to be happy, money doesn't matter. Nothing actually in the life matters. Internally, how you feel, how actually one can reach that particular realm and all of that. That's why the newer concept that wellness, however fine it may be, but all said and done, there is almost always a place for improving. And one of the area where actually we are talking about is actually there are, you're talking about behaviors in general, relationship and so many other such things actually extremely important aspect where the things go into. And when you are trying to talk about sexual medicine, primarily I believe that it is actually relationship problems. That's what actually we deal with. And when we are trying to talk about female sexuality, it is nothing but relationship pathology. And somebody was talking to me just few minutes back, there are some problems. See, if a woman has to marry man, problems are bound to be present. A man has to marry a woman, problems are bound to be present. All women, you want to be very happy in life means you have to marry women only, because you can think alike. Men have to be extremely happy in their life, they have to marry men only. No, you got the point? We match. You can't marry a woman and you can marry a man and then want to be happy means not possible. You got the point? There are a lot of compromises and a whole lot of adjustments what you have to make. This is what actually the science talks about. So mental health is one of the extremely important to this thing. When we are trying to talk about psyche, see, for example, if you ask any of the neuroscientists, they are maybe from IIT and major such big institutions where they're trying to decipher a simple molecule at atomic level and various things like that. But from our point of view, psyche means one may talk about from religious, spiritual, from point of view, the Atma to this, that, and 100 other such the things. From our this thing, that psyche refers to the integrated functioning of brain. In fact, we have used the terminology mind or psyche. In fact, when we are trying to talk about intimacy, relationship, and all of that, psyche, the Greek goddess, too. In fact, there are a lot of other hypothesis theories are there that we not just get into. Psychology actually deals with behavior in general. If it is a medical branch, in fact, we call it as psychiatry. So, and a few minutes earlier only what I have just mentioned to you that if structural understandable, decipherable problem is there. In fact, we refer to it as actually in the terms of what we call neurology and psychiatry. So these are all few very important areas. And when we are trying to look at about what we are going to understand micro analysis, and what we are trying to see anatomy, physiology, structural issues, and whole lot of these things. That is one way of studying. In fact, the neuroscientists are extremely involved with this type of a thing. Go to the minutest possible explanations and things like that. But many of the times we psychiatrists try to look at the problem from a little broader perspective, in the sense that what is actually happening in the society, social issues, relationship issues, cultural parameters, and whole lot of such the things, they matter to a great extent. That means these are the things. Same molecule, you take an example, the example of dopamine, whatever somebody was talking about a few minutes earlier. Dopamine at some particular point produces some problem. Dopamine at another particular point, it produces different problem. Which tract and where actually it is actually, in fact, a whole lot of issues are related to that. Abnormality is bound to be present, but somebody manifests and somebody doesn't manifest. Why actually this particular whole lot of changes happen? See, if you try to look at one of the earliest studies for bipolar disorder genetics, the monozygotic concordance rate reported was almost 100%. It won't happen that particular way. Naturally, just not possible that particular way. So there are so many other such as this thing, and one of the terminology, beautiful terminology that was mentioned was multifactorial. These are all the disorders. See, you talk about diabetes, you talk about hypertension, you talk about coronary artery disease, you talk about a range of major psychiatric disorders. They are all multifactorial disorders. There is something biology, something vulnerability, over and above, in fact, what is actually the environment, how it is actually operating, whole lot of difference that actually happens. That means starting from what we basically call from early constitution to early upbringing and many other such things actually play a significant role. And from our point of view, all of you might have seen, some of you young girls are there, you send an arrow, means which part you are focusing? Heart. Why heart? Because people believe at one particular time that all our emotions, love, this and that, whatever you talk about, this is there in the heart. That's why falling in love means automatically there is some problem. That arrow doesn't go outside. Actually, it stays there, and it is making so much of difficulty. That's why you are very quiet, very happy, and all like that. Even my wife says, "I was so happy before I married you." No, you got the point. The day I married, all problems started. This is what actually. She's deadly. Another statement she makes: "If you really loved me, you should have married somebody else." Can you imagine? See, the whole issue here is we believed at one particular time heart as one of the seats of actually our emotions and all that. But now we know that it is actually the brain, and the brain alone actually determines. This is what actually, in fact, talks about when you are trying to talk about brain basics. It is actually the brain which is actually responsible for all our these things. Even when you declare death, heart is dead, it can be replaced. The brain death as one of the ultimate culmination, what we talk about, is actually responsible. When we are trying to talk about functions of mind, there are many different areas, but condensed into three very major definitions. One, we talk about cognition, one we talk about cognition, and the third one we talk about emotion. Somebody was talking about it. I am not just going into the bipolar disorder mainly because I was told there are not many medical people would be there, but engineering and so many other people were. That's why I am just digressing to some extent to make it convey some important point. Each of these things are important. What you talk about emotion, what is that emotion means, you will find it very difficult. Sugar is sweet. But when we ask you to what is that sweetness you describe, means unless you experience, it is not possible to tell what it is. So cognitive refers to almost anything and everything related to the consciousness. You talk about the consciousness which is floating around to, in fact, you ask the name and he is telling that attention, continue something, concentration, you are aware of surroundings. That's what we talk about, orientation. And we remember and recollect past things actually we talk about. Memory, I am seeing, that is what actually perception is about. I am thinking and I am generating ideas all the time. That's what we talk about, thought. So There are a whole lot of things actually I can elaborate on that. I know what the world is actually happening, how I have to take flight and reach this particular place. That means a little more higher level cognition we'll be talking about. So these are all cognitive functions. Cognitive refers to, see, for example, this is where actually the whole lot of problem comes and the disorders we talk about. Anybody can tell me what is cognitive in psychological terms? Cognitive? Say, I asked that particular girl, you stand up. Okay, sit down. See, her neurological system is all right. But she could have almost always made a decision not to answer to, you have been called for giving a lecture and give lecture and go, I say, why you are asking me to stand up? No, you got the point? This is the volition, the will. She has to make a decision whether I should follow this particular instructions or I should not follow. This is the only reason why in the world you announce one beautiful gold medal and with a very big amount of money along with that. 10 students are there. 3 people will sit and study overnight and try to get ready for the answers. 3 will be moderately get ready. Another 3 will not get ready for whatever you try to do. This is what people, scientists talk about, inverted U-shaped curve, what we call the Gaussian curve. So, whole lot of things actually happen because cognitive aspects are extremely important. The will, what we talk about, is one of the major determinant of why actually somebody is successful or not, somebody is motivated or not, somebody wants to do or not. Emotive is actually one of the very common term. In our science, they talk about nervous and all of that. In fact, when you are trying to talk about bipolar disorder, it is nothing but mood disorder only. But what is that mood disorder? Say, for example, if I ask you, you will be actually struggling to understand. Feeling is, anybody, my wife says you don't have feelings. No, you got the point. The scolding, she will, 100 scolding words are there. The first word she uses is actually feeling. You don't have feeling. Very common word by ladies to their husbands. To their own husbands. All other men look very comfortable. For their own husbands, in fact, they are very critical. What is feeling? I saw that nice, beautiful girl. I felt happy. This experience is only this much is what is called feeling. I saw that nice girl and my heart has started beating. Respiration is going up. My eyes are shrinking. My legs are trembling. I feel like sinking. Now you got the point? It is a hedonic state, a disturbed state. You add to that. In fact, feeling plus physiology is equal to emotion. If feeling is sustained for some length of time, we refer to as mood. If emotion is sustained for some length of time, we call it as affect. All earlier textbooks used to use the terminology affective disorders. Bipolar disorder is an affective disorder. But now we don't talk about affective disorder at all, except that it is there in the bracket. We talk about mood disorder because you people are studying the molecules, various such these things and all, but we don't study about it. But overall, we are trying to look at whether he is happy, unhappy. Well, that's a type of a thing. Grossly, what we try to actually understand. So these are all. If you try to decipher, each of these words actually carry a different type of meanings. Of course, stress is related to the fact that serene water was there and you throw a pebble. This actually creates a whole lot of difficulty. We can crack jokes, no problem. No, in this, no issues. I have to talk to you with so much of this thing means it becomes difficult. Stress is related to something which is actually has created ripples. And those who are married, how many of you are married in this group? Of course, some are married and some are going to marry. No, okay, you will be able to understand at this level. Stress is when your wife is pregnant. No, you got the point. You are married and she is pregnant and she is not available for next 9 months, so you are feel little uncomfortable about. This is what actually the stress is about. Anxiety is when your girlfriend is pregnant. You got the point. It is a little more than what we talk about stress. Panic. Your girlfriend told she is pregnant and you came home, wife also told that she is pregnant. No, you got the point. Very high level of anxiety. Panic attacks and all what we talk about. No, girlfriend is also pregnant, wife is also pregnant. Depression or tragedy when you are not done anything but both are pregnant. No, You got it? I think now I have a whole of psychiatry, so much of effort we need to put it actually. In fact, I have explained to you all the common terminologies. If it is actually something more, something problematic, disorders, or otherwise, anybody can experience it. Mental illnesses are actually problems, extremely common. We believed at one particular time that we don't have that amount of stress, like say West. We are not that much problems in our country, but you talk about any number of disorders which are there in Western countries, in fact, they are all there in our country too. But the range of epidemiological studies have documented that mental illnesses are extremely common. Depression is so common. Either anybody in this particular room who doesn't have worries? See, you don't have worries. That means I've already got a case. No, you got the point. This is the first documented case. See, sometimes we psychiatrists go around and trying search out cases and all. No, if somebody says I don't have worries, immediately you have to make a card, make admission, and treat. Seriously, you have to treat. No, you got the point. When I am not able to understand, I have worries. There is a problem. You got the point. So, depression is extremely common. Any human being not depressed any time in the life, not possible to get like that. Genetically speaking, being happy or being unhappy, whatever it is, there are a whole range of chemicals and a lot of molecular issues come into picture. But all said and done, all of us are prone for developing one disease or other. All of us carry depressive genes. All of us carry manic genes. The point is how much we try to carry and how much we have become hardy. In fact, that's one actually which determines actually to a great extent how it. So depression is extremely common worldwide, and depression, people use it in very many contexts. Depression Bay of Bengal, you get rains. Depression stock market, it is actually depression on the road, depression on your cheek. No, you got the point. But all said and done, psychiatrically speaking, this is one of the major common disorder. And many of the reports, so for example, this Vijayawada and this particular coastal belt, extremely common farmers suicide and all reported here in Karnataka. See, somebody had made a loan of 2 lakhs, 4 lakhs, and he committed suicide. It is not related to the loan at all. There has to be something more major, significant underlying problem. This is what actually we talk about, these mood disorders and all. So depression is extremely common. And Deepika Padukone, I suffered from. In fact, when she told, there are so many celebrities who came out and told. See, when I have diabetes mellitus, I don't hesitate telling anybody that I am having diabetes mellitus. When I get coronary artery disease, I don't hesitate telling people that I have coronary disease. But to tell I am having mental illness, I was treated for mental illness, I don't tell. Many of the mental illnesses are easily treatable. 100% you can recover. But all said and done, we don't talk about it mainly because so much of stigma around that particular. So depression, see, for example, in 2004, it was considered as the third common cause. 2020 is supposed to be the second, but the WHO reports, they talk about this is already we are there in the number one position among all the disorders. 2030, unipolar depression is supposed to be one of the most common cause for morbidity and mortality worldwide. You don't have to wait for 2030. Already we are having the data to say depression is one of the number one causes for, in fact, morbidity and mortality worldwide. So mental illnesses, how common? I'm not going to go into the details, but just to give you a rough idea, see, for example, almost about 10 to 20 per thousand population have serious mental illnesses. You imagine that our Indian population is of 1.4 billion. So what is the extent of people actually suffering from this particular illnesses? It could be schizophrenia, it could be depression, it could be mania, but they all form one of the major chunk and actually have a good idea about. Minor problems. I'm having headache, I'm having chest pain, I'm having a little bowel disturbances, 100 other such things what we complain about. They are all part and parcel of, in fact, certain categories of disorders. So that becomes a number extremely high. Almost about 100 out of 1000 means, see, for example, in this particular hall, there are about 500 people, means there are a number of people who are already having problem. All of you have got headache sometime or other. You have headache? And then now you want to be a little careful answering. Na? So you have headache. That means there is another one person definitely has headache. Who is that person? See, women don't keep anything to themselves. They transmit and spread it actually. Say, husband is definitely one. She has in-laws means, in fact, they are actually having headache. So we have about 10 different cases in your house itself who are having problem. So extremely common. See, minor forms. In fact, one of the very easy way, there were some medical students. If you go to the medical OPD, gynec OPD, ortho OPD, or any OPD for that matter, 1/3 the specialty patients, another 1/3 maybe purely psychiatric, another 1/3 both psychology and this thing. That means this is 1/3 formula. In fact, this is where actually, in fact, we are likely to have people. I have just taken an example of depression to explain to you. What it means is the confusing puzzle is when to call somebody as having depression. See, we all feel sad. It is subjective experience. Objectively, we call it maybe the name we give actually depression level. But all said and done, if this particular problem persists and interferes with so many of his physiological functionings, so many of his social and other related functionings, then it becomes actually something called as a disorder. This is where the difficulty. There are a lot of studies which actually bring in very loosely a lot of other people, and there are some very rigid, strict criteria on which if you go, in fact, the whole range of figures that are available, see, south and the north, depression is reported almost about 27-30 per 1,000 population in the north studies. In southern studies, many of the studies earlier reported about maybe 5, 7, 8 cases per 1,000 population. This is because what are the way actually you have used the criteria. And based on that, in fact, there are different classifications which give different criteria. One of the most common thing what we try to follow is actually maybe the international classification of diseases, which gives, in fact, one of the approaches is actually they try to follow is the categorical approach. 1 minute later, I'll come. So depression is because of some particular reason, and depression without any particular reason, that is endogenous. In fact, it because of certain changes that happen in the body, because of which I'll get it. Everything is fine, but all said and done, the individual may be actually depressed. In fact, this unexplained because of the internal changes in the body and the whole lot of chemistry what people are talking about. They are talking about serotonin, they are talking about catecholamines, dopamine, norepinephrine, and things like that. They all indicate there are certain changes that have happened in the body. So there is a cause and there is no cause. In fact, that no cause is actually one of the most important points. And one of the most important points is actually our expectation. We can talk for hours together on this particular thing. In fact, my wife believes that her husband means she should have been like this 1, 2, 3, 4. To meet all her criteria, she has to marry at least about 30 people. No, you got the point. Different criteria meets all the things. You want to marry one of the best possible person. To get that best possible person, you have to marry how many people? No, you got the point. So one of the best thing is actually marry somebody and adjust to that. In fact, this is what whole psychiatry is about. You are not going to get whatever you wanted in that particular fashion. So this is what the expectation. I should have been first class. I should have been first to the class. I should have been this great, that great. No, you got the point. And this is one of the reasons a lot of women fall into a whole lot of difficulty. Say, for example, according to statistics, in fact, there are experts are there. If you decide to marry, what is the chance of getting married? What is the chance? How much? Loudly. See, there is only 50% chance of getting married. No, you got the point. That's what actually statistics says. You want to marry a man who is 5 feet tall. What is the chance of getting married? 25%. You want to marry a man and who is 5 feet tall and only son to the parents. 12.5. See, more and more criteria as you add. Ultimately, you wanted some extraordinary Superman to marry, but you marry some hopeless looking fellow, not because of anything, but because every variable you try to add, that much more chances of getting married comes down to a great extent. So these are all expectations and the related things. Gender-wise, see the pure depressive disorders, depressive spectrum disorders. In fact, depressive spectrum, what we talk about, that also becomes part of what we call a whole range of bipolar disorders also. See, pure depressive disorders, in whom you will find? Among women. See, by majority of the cases, you look at the whole range of epidemiological studies. Majority of the people have reported depression is extremely common in case of women. That is because if you want to see depression, it is actually seen in women mainly because it is unadulterated. I can see depression. I can see the play of emotions. I can understand majority of things that are actually happening. In case of man, it is almost impossible to recognize depression is present. Not because of anything. See, for example, you are in love with a boy and he told, I don't want to marry at the end of 1 year. Mummy, give me 10 rupees, 20 rupees. Why? You want to go to KRS and jump from there and die. Now you got the point. Is depression. But look at the boy. In the movies also, that's what they show. And in fact, natural life also, he starts drinking. He starts singing songs. He's so happy. No, it looks like he may be expressing certain ideas. So it gets adulterated. Alcoholism, other social problems, and many other such these things. That's why, in case of man, it is almost impossible to recognize. And more than anything else, in fact, one of the most important complaints from the women is actually the men cannot show expression. How many women who are married and who say that my husband talks, shares a lot of things with me? How many of you are there like that? Who are that lucky? If you have married a man and he has shared all the things with you, you have to take a photograph and put it in every college, every wall and all that. No, you got the point. You are not going to come across any men like that. Women, the expression of emotions. See, you have been trained to express emotions. Men have been trained not to express emotions. Are you a girl? This one, that one, and ultimately, in fact, he becomes such a hopeless wreck as far as emotions are concerned. And whole lot of disorders, if you try to talk emotional disorders, they are present, but they don't manifest that particular way. This is actually the story with this thing. So depression is reported 2 to 3 times more commonly in women, and this is one of the things. And how actually to overcome this particular point? There are dimensional concepts are there. There are categorical. If this is present, one of the core features according to ICD classification, if you take, feeling sad, not getting pleasure out of the regular activity, feeling weak and tired. DSM classification, if you take, there are only first two are actually the criteria. There are a few more other physiological changes, melancholic changes, vegetative changes, biological changes we talk about. Appetite, weight, bowel, diurnal variation, libido changes. Now you got the point? Suicidal and such areas, guilt, and many other such parameters come into the picture. So, based on how many are present, you classify them as mild, moderate, severe, and the range of how actually to go about different classificator systems have different ideas. Many of the times, both anxiety and depression happen together. Old teaching used to be there. If depression is more, you call it as a depressive disorder, and if anxiety is more, you call it as anxiety disorder. That particular, all those concepts have gone off now. And combination is actually what there is no depression on this earth which doesn't have associated anxiety. There is no anxiety on this earth which doesn't have associated depression. Both go hand in hand. And if somebody is talking about suicide, this is what, because in fact I just wanted to focus this particular point, because you may be having your friends, your classmates, your roommates, your hostel mates. If somebody tells you that I'm feeling like committing suicide, I get these ideas, don't ever try to neglect. In fact, one of the important message of calling me here is, even if for the fun sake somebody is telling that I feel like ending life, this actually needs a serious looking into. He should be, in fact, whether you are able to help, his parents are going to help, or there are professionals who are going to help, but help is definitely called for. Don't ever try to neglect these individuals, and this is one of the important message. The third important thing is actually, somebody may present with anxiety symptoms. Somebody may present with obsessional symptoms. Some may present with dissociative symptoms. Some may present with psychotic symptoms. These are all different manifestations. All of them may be having one underlying, say for example, mood disorder as one of the important criteria. But which one actually, who presents this actually changes. See, when we used to have earlier obsessive compulsive neurosis, but now we don't talk about obsessive compulsive, we talk about obsessive compulsive disorder, because unless proved otherwise, depression is one of the most important common cause. You look at a whole lot of treatments available, all of them are antidepressants. All the other psychological and other related therapies to some extent possible, but all said and done, these are all related to the same common disorder. Headache. You try to look at migraine, one of the extremely common among women. Whole psychopathology, if you try to look at, it is actually the serotonin and other related phenomena. So this is what actually is about depression also. So there are many things which are common, and what one presenting to you is actually based on. In fact, one of the old hat theory was actually that organ weakness theories. Why somebody presents with headache, why somebody presents with chest pain, why somebody presents with a different type of these things, because psychologically speaking, at some particular point, vulnerability and something happened. See, somebody developed, father died of paralysis. This lady will present with symptomatology which is referable to that particular fashion. Somebody else was having headache. In fact, many of the times, actually mimicking certain things are extremely common, and these are all actually very well known phenomena. And in psychiatry, sometimes, in fact, we had one recently lady. She was very commonly getting headache every week. Last 2 weeks there is no headache. That's why she has come for consultation. No, you got the point. Why I am not getting headache? No, you got the point. She has got so used to headache. Why I am not getting headache? She was a little upset about, and she wanted to know. So there is, in psychiatry, what happens based on what are the criteria which are dominant picture. Based on that, we make diagnosis. The common theory or the common hypothesis related to many of these theories are the things what we talk about, either depression and things like that. We did a lot of studies with Dr. Jagannath Rao related to Parkinsonism and related to other certain medical disorders and all of that. Whole lot of data is available which talks about, in the case of medically ill and majority of the areas, depression and things like that. Psychiatric disorders in general, or take depression as one of the prototype disorder, extremely common, maybe 2 to 3, 4 times. If you are trying to talk about, see, for example, if somebody has developed coronary artery disease, somebody develops coronary artery disease and not depressed, very unusual. So it is 2 to 3 times more common in certain types of disorders. And people were talking about Parkinsonism and disorders like that. So again, ultimately the base level, if you try to look at what are the problems, that's what precisely is about, the type of problems what we actually encounter. Coming to bipolar disorder. See, bipolar disorder, historical aspects, I will not go into the too many details. But initially, all psychoses were grouped under one. Kriplin actually noticed that there are some disorders which come and go. There are some disorders which are actually continuous. Actually, they deteriorate, what he called as dementia precox. Those which actually come and go and they don't deteriorate. In fact, he called them as manic depressive psychosis and disorders related to that. So, lot of such things actually happened, and we are all well aware. Historically speaking, in fact, this particular concept has developed nearly 1.5 century to talk about. And when we are trying to look at depression and bipolar disorder, point of difference is only this much. In case of depression, it is only that down phase. He feels sad, anxious, and whole related symptomatology. In case of bipolar disorder, it is actually biphasic in the sense that at one particular time he is actually high, there is another particular time he is actually low. And this particular variety, I am going to, another one slide is there where we are going to talk to you in little more in detail. Almost about 70% of the population, depression is the first one to appear. Then they move to the what we call as mania. In a small percentage of individual, mania itself can be the first manifestation. Then they move into the depression. But the problem is, when actually very active symptoms are there and very easily recognizable, people recognize. But there are a lot of things actually not possible to recognize. That's where actually the whole lot of classification systems came into the picture. So currently, when we are trying to talk about bipolar disorder, what is necessary is actually presence or absence of mania, or maybe a little slower version, hypomania. Depression is nowhere brought into the picture at all of that. They might have suffered but not recognized. They might have suffered but not documented. They might have suffered but never complained about it, and it is a self-remitting illness. They might have recovered. So when we are trying to use the terminology bipolar disorder, the point what we have to note is actually it is all based on whether presence or absence of mania and hypomania. So depression is not actually, but a cycle when we are trying to talk about, there are the two phases. It could be depression first and mania later, or mania first and depression of subsequent. So this is one of the very classically understood, and this particular message we want to. People move from one to other phases. One episode may be hypomania, another episode mania. From hypomania, he may go into mania, a little high all the time, constantly. In fact, this particular individual is recognized as very active and hereditary hyperthymia, various other such things. Down, in fact, we talk about actually the depression and related, mild, moderate, severe, whole lot of such things. So, going up and down, bipolarity. This is one of the reasons why this terminology actually has come into the being. And how frequently actually the episodes appear and all, based on you try to classify differently. There are people who get episode every year once. They are called as almost anniversary reactions, anniversary episodes. If there are 4 episodes in given year, in fact, we call them as short cycler. There are actually, we have come across people who actually change cycle every 24, 48, 72 hours and all that. I still remember there was a Muslim girl was brought when I was postgraduate student. Her pattern of living for about 15 days, she takes bath every day, makes up, and a lot of activities she does. Another 15 days, she is all right. They take bath once a week and all, like that was actually the usual pattern. And another next 15 days, she doesn't take bath at all. No, you got the point. This much only was the information available. But now we know that there are phases about 15 days she is high, there are 15 days she is euthymic, another 15 days she is down. This particular, if it is repeating in this particular regular pattern, we call them as a circular type. But many of the times it could be more number of manic episodes, more number of depressive episodes, and multiple permutation combinations are actually what we come across. In between, we have a whole range of other things, bipolar spectrum disorders. Bipolar spectrum, cyclothymia is also included part of it. Actually, slightly up and down moods, actually people have documented too. The range of things, starting from presence of obsessive compulsive disorder to tics and such other things also have been brought under this what you call as bipolar spectrum. So, starting from mild variance in the mood to significant changes in the mood, and which actually go to an extent where it could be psychotic level disturbances. This is what actually the story about bipolar disorder. No two individuals would be same. You might have noticed that this particular individual is actually hypomanic today. 2 days later, it could be mania, with excitement. Now you got the point where one has to tie his hands, legs, and try to restrain and control. So, whole permutation of changes in symptomatology actually has been done. Etiologically speaking, there are a whole lot of theories actually to explain biology, psychology, and what we basically call the social and environmental factors. And when we are trying to talk about biology, genetics is there. Molecules are actually what they were trying to emphasize. They are trying to understand even the minute changes which are actually happening and in these individuals, what it is. If there is one particular disorder in psychiatry, where we have something almost like a medical disorders information available, it is actually depression and bipolar disorder. Almost all other disorders, we are still very far away from actually to label that this is actually which produces this particular difficulty. And when we say somebody is recovered and all, like in fact, it is almost impossible. See, when somebody develops bipolar disorder, it is a lifelong disorder. It is almost like take it for granted somebody is having hypertension or diabetes. All through the life, they may need to treat. If you don't treat, episodes become more severe, episodes become more prolonged. The inter-episode interval actually keeps coming down. Ultimately, you get a total psychological wreck. So, treatment is an absolute necessity. Many of the times, many of these individuals never understand that actually they suffered and they created problem, or they got into a whole lot of difficulty and all of that. This is one of the major difficulty. And relatives, initially they will fail to understand that why this particular fellow again and again why he gets into this particular type of difficulty. So a cooperative, relative is there, very easy to handle. And this is one of the reasons. Say, for example, if a man develops illness, women usually cooperate as far as the management is concerned. When a woman develops this, husbands are never bothered about their wives. Now you got the point. We never able to treat properly, not because of anything, but there is a relative who is not taking care of her properly. So this is one of the very common difficulty. And when we say remission, at least for about 8 weeks, there are no symptoms. And in that particular 8-week interval, the symptoms are less, but still the symptoms appeared again in a significant fashion. We call it as relapse. or if beyond that particular thing, if somebody has developed the symptoms, we call it as recurrence. So these are all little technical terminologies. If somebody has any questions on that, we'll try to talk about. So initially we did certain studies which are actually pedigree based studies. They were all very simple, common this thing, looking into a whole lot of people. And one of the cases what we had described there, in fact, bulimia, eating excessively. In fact, this particular individual used to eat during certain phases excessive food, almost about 1 kg, 1.5 kg rice in one particular given time. That is the amount of food actually he eats like that. In fact, there is something odd about this particular fellow like that. And when we could go into the details, there were almost about 16 people with this particular disorder in the family. We could trace it out. And one lady was almost about 102 years old. So initial studies used to be that particular, but now we talk about genetics in a very different fashion altogether. In JJ Medical College, JSS Medical College, we did studies related to what we call as the DNA and other related phenomena. They were all a little gross studies, but CFTRI and the Rare Minerals Project, I still remember some of the scientists involved in that particular whole work, study related to single strand, double strand. In fact, just I'm running to show, it may look like some of the gross type of studies at that particular time, but all said and done, we could win awards because of this particular pioneering studies like that. What I'm talking is about just about 2.5 decades old research. But all said and done, they were all indicators of some changes that are happening inside the brain and which is leading to certain types of difficulties. Trace metals. This is one of the other area where we did. In fact, ours was the only study where almost about 14 trace metals were analyzed in greater detail, and more specifically, the copper, iron deposit in certain particular areas, creating type of difficulties. In fact, these were the few things: iron, copper accumulation leading to quite a bit of problems. Where and what? In fact, in depression brain bank, we used to do studies related to, say, we're all well aware depression means it is hippocampus and certain areas. But when we did study, it was actually nothing really we could find in hippocampus. The later studies are available, it is not in hippocampus, it is in the amygdala. And unless illness has gone for some length of time, these changes are not found in some particular parts. So this is the way the research progressed, and now ultimately we are trying to talk about what is precisely happening at what particular level. Serum trace elemental levels in case of Parkinson's disease. In fact, when we are looking at Parkinson's disease, computational analysis and other related things, unless you differentiate mild, moderate, severe, overall subject and try to look at the trace metal changes, you may not get at all of that. Somebody has progressed to a moderate level and more maybe the severe level, you will find certain changes which are totally different from some individual who is actually in the beginning what we are trying to talk about. So genetics, the range of studies are available. I'm not going to elaborate because we're all will be studying in a much bigger fashion and much deeper and sensitive way. And when we try to look at course and other related things, to put you in brief, bipolar disorder, those who develop the illness very early age, they continue to suffer in a bigger way with frequent episodes, which are bigger episodes with at least less, in fact, what called the inter episode interval. This is one of the very common these things. So, if it is in case of a female, it is in case of a male, there is a whole lot of different types of things people have actually documented. But majority of the individuals, somewhere around that very critical area, that around 18, 20, 24, in fact, this is the time the commonest, in fact, reported onset of this particular illness which has been documented. But illness like mania can appear anytime, any phase of the life, and this is one of the points what one should be. So there are few things, points, there are studies document that if it started early, how much time is there? How many minutes? 10 minutes. So, nature of onset, at what age the illness appeared, can actually make a whole lot of difference. Episodes. There are some individuals who may come again and again with mania and again with depression and combination and circle and other related type of things actually I was trying to talk about. There are studies available actually in a given lifetime, how frequently actually the individual likely to. Depression, mania, and in fact, that is one of the most common form. Mania first, depression subsequently, and lot many other permutation combinations are actually documented. And when we are trying to talk about mania in case of males, many of the times alcoholics, primary alcoholism and secondary alcoholism, we try to differentiate. Somebody who takes alcohol suddenly started somewhere around 30, 40s. This is not related to the regular social drinking at all. Even in depression also, somebody presenting you for the first time some anxiety symptoms, some dissociative symptoms, some obsessive compulsive symptomatology, it should never be treated as primary those type of neurotic other primary disorders like that. It is almost always secondary to something what major disorder. It could be either depression or bipolar disorder. This is the other one. A female started drinking alcohol, particularly say somewhere around the 30s, 40s, away from a middle class. It is not actually a alcoholism case at all. It is actually either mania or depression or something like that. In fact, the bipolarity is what actually we should keep it in mind. There are some communities which actually discourage some of these type of habits. A Jain, a Muslim, in fact, start drinking. Don't ever try to think that this is actually related to some of these drug habits and things have actually come up. So, like that way, there are a lot of other things actually one can talk about. Bipolar type 1 and type 2 refers to, of course, type 2, where only hypomania has been documented, and this is coming again. If it has gone to the extent of mania, even one episode documented, they are all grouped under actually called as bipolar type 1. These two may be all right, but there is a family history. First degree relative is having mania. In fact, that's what actually comes under bipolar type 2. That means there is a strong emphasis, bipolar type 3, the strong emphasis on the genetics of this particular disorder. There are some other categories are there where actually you do treat somebody with antidepressants, they develop illness. In fact, antidepressant induced mania. But this particular category is actually still quite vague in the sense that unless you are vulnerable, you are not likely to develop mania. So it has to be described in some particular fashion. So predominant depressive polarity, it is among the females. Predominantly depressive, in fact, manic polarity, primarily this is actually reported in case of males. And what all the type of symptomatology is actually the individual presents. Course of bipolar disorder in India, I will not going to elaborate hardly much, except that, see, when we did a study for ICMR on acute psychosis and how actually, which was found was, see, for example, fever, inflammation, and something related to that as one of the least reported problem in case of Western literature. But in Indian population, for the psychosis, the fever as one of the most common factor. Almost about 15% of the individual had the history of fever, and following which actually they had developed the symptomatology. So there may be wide variation actually in different countries how actually the picture changes. Unipolar depression or depression is extremely common in our country. Do remember that this and contributing to the whole rate of morbidity mortality in the individuals, and major depressive disorder is extremely common. Nowadays we talk about bipolar disorder and alcoholism as part of the 10 common disorders what we encounter in Indian population. Somebody is having hypertension, somebody is developing coronary artery disease, somebody is developing other physical disorders. Almost majority of these are the extremely common presentations. See, for example, eating. Some of you might have noticed, or you yourself, when husband quarrels with you, you eat or you don't eat? You eat, is it? That's fine. You are a little different I think. But many women, when husband is there, they don't eat. Once that fellow goes out, means baga baga like that, the whole empty the fridge. They try to overcome their anxiety by eating itself. So I'm eating very less, but still I'm putting on weight, means because you are eating chocolates, you are eating this one, that one, and so many. Eating head of your husband itself is more than sufficient sometimes to put on weight. Suspicious, psychotic, and such other symptomatology. Why I'm telling is, a pure bipolar disorder presentation will be a little different from the severity itself may manifest in the form of psychosis, but appearance of something related. Now we have whole range of disorders, what you call as schizoaffective and such other things, where the treatment has to be tailored to take into both the cases. The range of drugs what we use. You talk about antidepressants, You talk about antipsychotics, you talk about benzodiazepines, you talk about so many other supportive things. In fact, sexual problems are treatment emergent sexual problems. The disorder itself can lead to quite a bit of difficulty. I still remember there are quite a few people. In fact, just like Andhra Pradesh, Karnataka is also another place. If somebody says, I want to marry second time, when first wife is there, first we have to rule out bipolar disorder. No, you got the point? There are people, in fact, they become so energetic, active, hypersexual that, in fact, I want to marry and whole lot of such these things. And more particularly, if they have money and all that, marry and then subsequently repent why actually I did that, because he's out of that particular illness phase. So bipolar disorder and sexuality, we have a lot of material on that particular area. Later, Dr. Jagannath Rao was telling, we'll be having some sessions and all of that. So ultimately, whether it is actually depression or mania, they actually take a particular way of course, and one should be actually watching closely. Important point what we have to remember is actually the lot of things actually which can trigger. What it means is, see, there are few things which actually lifestyle issues. Somebody should sleep adequately in the night. I didn't sleep tonight at all. If I am predisposed, that may be more than sufficient trigger. You look at epilepsy, you look at bipolar disorder, sleeping less, some other stress, whole lot of things actually can trigger the illness. So that's what actually one should remember. So this is what actually the personality. All of us have some things actually which God has given. Early upbringing, more love and affection, that can create quite a bit of difficulty. And those who have gone through quite a bit of difficulty, this is called as a hardiness, who are having that particular capacity to manage life. In absence of it, actually, it can create quite a bit of difficulty. As I was trying to tell, anything, everything on the earth can be a source for a trigger for bipolar disorder if there is actually predisposed. It is almost like burning at both the ends. This is what actually people talk about. If support is not available, they can break down very easily and they can deteriorate very fast also. This illness from that particular point, impact treatment means these people need to be treated adequately, properly. And see, if you look at bipolar disorder, lithium is one of the very frequently used terminology. Is one of the gold standard drug for bipolar disorder. But whole lot of literature speaks with lithium alone, only around 50 to 60% of the people can be brought under control. To get him under control, some of the individuals have to be added second mood stabilizer. Say, take sodium valproate. 60 to 70% people can be controlled. That means there are another about 30-20% of the people still not under control. So you have to add another third, lamotrigine. So many other such drugs are available, carbamazepine. With the three drugs, 70 to 80. Fourth mood stabilizer added, 80 to 90. That means still another about 10% not possible to control at all. Like these are all few of the cases with best of the possible treatment, we don't succeed. So what I am trying to tell you, don't look at so many drugs are written for some individuals. It is not polypharmacy. Sometimes it may becomes necessity that different groups of medications, mood stabilizers. Somebody depression again and again, antidepressants. So you have to cover it with mood stabilizers. So ultimately there are so many medications which actually people find it very difficult. Why I should take so many tablets? I am all right. And many such things actually people come and tell. In fact, they're irregular with the treatment. Leads to quite a bit of difficulty. Whole lot of psychotherapeutic techniques for depression in particular. Of course, hypomania one can work on. The mood stabilizers, antipsychotics, and some individuals respond to electroconvulsive therapy. Deep brain stimulation to this, that, and so many other newer treatment techniques are available now, which in fact people are trying to make use of. Whole range of antipsychotics. A day was there when only with about 2-3 drugs we used to play around. Now there are plenty of drugs. You talk about antipsychotics, antidepressants. How you select, whom, what you select, how long you will give, to what extent you will adjust the dosage, and how your permutation combinations are actually are thinking. It all depends from individual cases. Some of the most recent drug that has come from India is actually endoxifen. We were part of this particular multicentric study, wherein this is one of the newer mood stabilizers which acts on certain totally different mechanism. In fact, what we call protein kinase C inhibitor, and this is one of the newer drug in the horizon. I am very proud to say that this is one of the India developed molecule, and some of the Western people are doing this particular study in case of mania and all in the other countries now. So There are a lot of such things are there. What it means is bipolar disorder is extremely common. Various forms and ways actually it can actually present. Recognizing properly, treating adequately, extremely important. Sometimes it may be life and death question, including suicide and such other things are very commonly reported. Many of the family and lot many other such things we talked about may be related to this. Some people label them as personality problems and whole lot of such things. It could be the minor forms of bipolar disorder. So all these parameters you should keep in mind. In summary, bipolar disorder has a recurrent and chronic course. Significant dysfunction can happen. Course specifies help in proving certain specific aspects. Factors including course and outcome, one should actually study properly and help them adequately. Predicting the outcome on the basis of past observations can help because keep on changing doctor to doctor, center to center is not going to help. A particular doctor can understand why actually this particular. Very recently, one of the Marwadi patient we were trying to treat, we had to keep many different drugs. Earlier, he was treated at least 4 places, including close-up in an individual. They were not willing to bring him for follow-up at the end of 1 month, and they have gone to another doctor where he has stopped majority of the drugs, and again he has full-blown relapse. So, long-term treatment from a specific doctor extremely important, and carry home the message that all these individuals, if taken proper interest by the family and the doctor, they can be helped to a great extent. Thank you very much for wonderful opportunity what you have provided.
Any questions?
Okay.
So, I'm keeping it on this one. Okay.
Thank you for the wonderful presentation. I have for psychiatrist was again. How for the medical science of medical writers? For example, CT scan or MRI scan, patient also. What are each differences? How for it help in diagnosis? Because
The problem is we are working in a hospital where medicine scan. We tell them CT scan not necessary, still they will go and get the CT scan. There are some findings, but all non-specific findings. Any individual bipolar disorder, they are not person of time. Integration in age of being movement, but they are not diagnosed. Observably, hopefully, with the and so on. Maybe something
person was finding hard work. Imagine that it's around 28 years. It's very kind of frustrating nowadays. 20 is not the option. So, in that case,
context is important. Spying that out and rate of idea of the 27 of the month's average. I mean, one percent. If this individual is being depressed, this depression is not major depressive disorder or bipolar disorder. You got the point? I am put into any stress for that matter, any hours, and any such things, like inside. Reactive secondary. So here the neurological findings are helpful for making understanding what is actually the spinal cord. It is not going to help you if it is depressed or not. It is a legal diagnosis.
but most of these patients are suicidal. They will be that case.
Point is, suicide ideas can set whenever a quarrel is my wife should have come suicide. Now I have taken 5 crore and insurance. Not even one she has spoken about suicide. is good, but also in that. See, this particular expressing is not good. And final part is your definitely 100% and this depression should not be labeled as ill. This depression is called as second depression. There is a moral by somebody dying, mother dying. That we don't bring equity to the same, that we don't exactly understand what is the spinal cord, not for understanding depression. There are there. In fact, that's what actually the people are studying around. People are doing PhDs. A lot of research is happening. But we have not reached this stage where if this happens, this is equal to this. We were talking about a lot of biomarkers are going to whole range of factors. Take an example, diabetes. Take an example, COVID. So many biomarkers affected. What extent affected to some extent, but they are not strong enough or sufficient to say this is what malaria, COVID, again, they are not this particular neurological psychiatry, almost always a diagnosis of so, how you read the question is by history. Second, what method? The history. Third method. The history. Nothing but there is no other way can be done. We are not that this slow. So, individual techniques, how actually one start the how actually see it, how actually see what the you know about mental illness, sexual problems. You say in front of me, talk about separate distance and point concept. You got the point. So, how you practice confidence, just not judgment. Not judgment means you bring a low point. It's a somebody's a girlfriend, you have a girlfriend, you got a point. On judgment. So, there are a lot of the 16 most important things for practice. Confidentiality. More than willing and more than happy actually go forward and explain. Absolutely, after you don't have time, just like we have on that's why actually I was trying to tell you. Proper information not available in these people on diagnosis. Proper information available in the picture changes. See, one of the what is actually happening to you hostel you are creating some behavior problems, some problem. Who is the best informed actually the information? You give your parents, your parent are not but to know about your problem, you need your movement. So you got the point. And dependent on this. So there are variables related to the patient. one survey, state, surprised to see that population in the day, one case because the demand has slow again, the geographical area problems.
Thank you, sir. I have a question. What is the effect of visual imaging to having depression or the extreme bipolar disorder? Because visually something that most of the past images that they have been is there any studies that are going visual imaging and patients with depression like anxiety?
I have opportunity to say that so this type of major is extremely complicated. Equals we find it very difficult to interpret as positive. An optimist will feel that what he has got is great, but a depressive will feel that it is something absolutely not. There was an interview, not 600. What about after 600, one is not asking but she's so miserable that not happy in this world. 600 or 600. There are 35 marks out of 100. So happy. So it all depends on how we how it depends how we feel. Simply happy or the children also something obsessive compulsive uncasting personality. Uncasting personality, say for example, how many of you would like to marry the person responsible, conscientious, hardworking, hard feeling, when you see, we have not married. The worst possible person that all these fellows will have coronary arteries. They will have gastric question of problem. They will have this one, that one, 100 other things. You are doing it naturally. I tell you what I in our college. You know what I married my classmate. We did a mistake. Very mistake. She was telling a ridiculous story. Sorry, used to come to the lake. We used to sit and study. That's what sit and study. He never used to look at girls. See, a boy doesn't look at girls. You should never marry. Somebody takes it happiness. These are all the worst possible colors. have a boss who is very individualistic, very disciplined. You should be happy or unhappy. You should be happy because this is not going to be for long. You have to be simple personality. You should be happy. So, there are some and then one another person came from here from principal was very strict. One day we were there in front of the secretary, 8:45 is there. We all saying that 50 minutes later he goes at 6. Come early, why you not go to the secretary and avoid the student? All products. What is that person doing? He scolds me, I'm not happy. But he's scolding the way he's supposed to go, foolish ones. See, why actually somebody presents in what particular behavior or particular answer. But somebody thinking, what exactly what way? So, be comfortable, be relaxed. I always say, before going for the exam, previous day, very important to do. They say in my shop, last week, 16 regarding movie and for 3 months. Lot of us struggle, I can't remember anything. Imagination is one of the very because it also that particular capacity positive. That's what. See, impressive brain means thinking bad about oneself, thinking bad about the world, thinking bad about the future. No, you got the point. Everything is there, everything is present. In fact, the very recent aspect about there was one senior Ministry officer about money. Range of money, very rich people. His daughter was married there 15 years later. These were already not sleeping, restless. What is that they think? I don't know what happened. Another one, he's famous. Not good. He is. There's no reason at all, but so imagine all the possible scenarios. I will not be alive to see what I did. I will not be able to think of things. I will not be able to. This is the question.
Another question is, I have a meeting psychiatrists or other medical what is your stand? What's your
See, some extent, all of us can be promised. You got a point. I am married, and I come across the next one. You get a message, she has pluralized peace. This is happening day, you have every time. You got a point. How we make use of it, our thing. And give another example. I will be PG. One senior PG came to see, welcoming your husband for its home vehicles. You should be upset or you should not be upset. She was not upset, she heard. Who are hungry that much better? Because this is happening every time, everywhere. But this as a concept where all can be used, people have different others can be used. See, not others, we talk about it. Not others, not others. Not others is. What else? Consciousness at the level or bring it out the level
combined this so generally I
somebody is having severe depression, it causes around second one is actually self-regulating disorders, depression. Shows severe isolation that she should be admitted. Then it would, when they would discuss another thing, small dose of somebody. Food is very cheap. There is a point. But another is possible dosing of multiple medications in other persons. Almost always should be common among before I saw. There is another phenomenon which is called repeating small substance. This can ultimately something again. And there are so many ladies now. Don't do this repeated eating on the head. Eating before too much suppress the capacity to do that. These are all life events, and many of the times life events there are a number of units here for psychiatrists. Psychiatrists, they would take part in like every day one of psychiatrists comes and teaches you how to see, point of difference is psychiatric patients get well and walk, psychiatrists continue to stay in the hospital. Yoga is not beneficial. Nobody is telling they are not beneficial. Yoga alone is not become the use. It can be one of the complementary other things people discuss.
The doctors really execute like ICT and purpose. But my notice like you said women are more expressive than depression, men are less expressive. And I have this same situation like when I was in the depression, I tried to communicate with a different people. But I don't even communicate. The voice is dominant, but voice won't. But is this skewed by the society or it was we have a students of arguments or subsequence?
Developmentally speaking, always language was girls are boys. What is the caution sequence? And if they are not translation, so you have to find him on that. What he refined, there are peoples. And among see what are the burden is actually talks about 7 times not the examined marks what is the burden. Language is not the influence. They have been endowed with that burden. See for example, there are not other differences. See for example, men's brain is bigger and women's brain is bigger. Men's brain is like desktop, big size, low capacity, wrong connections. Women are laptop, small small size, big capacity, hardly any leaks. Say for example, fortunately, my brain works. But when I look at a gun, it stops. That weight is not around me, actually slowly stops. We are all getting carried away with things. All testosterone dependent. Testosterone dependent what to say happens. We get one of those disorders. We are almost always restless. We cannot sit at one place for a long time. You go to any government office and any other office, you are sitting and working days on the same. All communication disorders, unless specified, they are all male sex disorders. Autism, male disorders, are male disorders. Always deficient, not handicapped. Our hearing capacity, 30% acuity is less. That's why you might have noticed your father only says that the type of maximum too much Kannada. And that too, he goes that way that he cannot understand the multitasking. Women cannot multitask. We can do one at a job. See, for example, very how to overcome this? You tell him 1 kg rice. Tell him 1 coriander. Rice, coriander, and half kg bun. Isolation. Now, brain doesn't work for that. You ladies so comfortable. Or we men, there are handicapped individuals. So, you have to do one task. You have to understand whatever you are doing and not able to go near the ear and only one liter weight time. So, you got the point. Second, don't tell them very fast, very slow. You got the point. We understand this. And we are marrying a handicapped girl and we are expecting an extraordinary superman to come to meet us. When that same hours is a bit, see, one of the best way to do is actually if you beat. Otherwise, what happens to you? See, this is what I think that the society in the sense that only way we can overcome this is by living. We got the point. We are making use of that particular effective. That's one. Wherever women have made a decision to come out of this particular game, they have done extremely. Which is the strongest sex? Sperms में there are two types of sperms. There are different sperms. X sperm and Y sperm. Egg is only one X. This Y is a weak one. It can survive only for 24 maximum 48 hours. X sperm can survive for going to 70s. This is one of the reasons why 70% of the time natural pregnancy is girls. 70% of the time natural abortion is actually boys. From that particular level. You are growing up. We call you weak for small things, you are so weak. But the second day, the best thing can be from only already saying then at least all these disorders, you guys, we don't have the capacity to express. When we don't have capacity to express, we are being suppressed from expressing ourselves. What it means. Say, for example, if I need as a name what, take an example, I'm 5 years or 7 years old. You have not available, so on. You have been But you, girls, we might always we are so happy that in that you want so much energy. That's why you don't have history and lessons. Always not even mistake about always research is good. Many in general, if somebody is extraordinary in that, say for example, extraordinary, he is an exception. You got the point. He is having more feminine traits. People are very extraordinary. And men are not developed the capacity to understand emotions and see there are people so well, but he doesn't appreciate. By silence, he doesn't understand. See, when speak himself, he doesn't understand. How do you silence can understand? See, tomorrow is your birthday, what you must say is, tomorrow is my birthday, I want condolence inside. You bring condolence inside. You should have understood your feelings and you should have done all the things. He is eating very well food. That is, you have prepared very well. It's appreciated. Sorry. You should have told him, very nice and all this, you are doing this. It's not possible. See, the point is, if you have tell good things about this, it's not the so I like something. So, all the mechanisms meant.
Thank you.
I would like to thank Dr. T.S.S. Rao sir for his wonderful speech on neuropsychiatric disorders with exemplifications, and I must stress on this word, the real lifetime examples, and I came to know the difference of the terms of stress, anxiety, disorder, and mental disorder with live examples. Thank you so much, sir, for enlightening us with the real life examples. And the session went on very lively, and our participants as well as the students also got enlightened with your speech. Thank you so much. And ladies and gentlemen, and dear participants, let's break for a small break for tea. And within 15 minutes, we'll assemble here for another session. And your refreshments are ready of your right side. Yes. We are going to have the next session by Dr. Anita Mahadevan ma'am, Professor and HOD Department of Neuropathology, NIMHANS, on biomarkers in neuroinfections using proteomics. So within 15 minutes, we are going to assemble here for the next session by Dr. Anita Mahadevan ma'am. in neuroinfections using proteinics. Let us invite Dr. Anita Mahadevan ma'am, Professor and Head of the Department of Neuropathology, NIMHANS, Human Brain Bank, Bangalore. Please, ma'am.
Good afternoon. I think I must first thank my previous speaker for waking everybody up. After that performance, I cannot match that. But I think, in all fairness, the next session should have been by his wife to know her side of the story. Yeah, thank you, sir. So I'll begin by thanking Professor Rao for his very kind invitation. We collaborated with him way back in 1998-2000. And honestly speaking, we haven't, I think, met after that. So it's a real pleasure to be here. Thank you very much. I'll echo what Dr. Srinivas said, that we've enjoyed a really warm hospitality and we're really, really happy to be here. So thank you. I have taken a small liberty going by the very mixed crowd that we have here, which I think is a great achievement of Dr. Rao, bringing in science, technology, engineering, medical, everything together. I've changed the topic a little bit. What I'll be telling you about is about the brain bank and how we have served neuroscience research in the country. But before I start, I would like to dedicate this to my mentor, teacher, who started the only brain bank in the country way back in 1995, and that's Professor Shankar. So what I'll do today is very quickly go through what is this brain bank about, why do we need it, and how has it really helped, and what are the challenges that we are going to face. So to start right at the very beginning, there have been several minds who have been pioneers of discoveries. And the first is probably Hippocrates, who put in this concept of what's termed as encephalocentrism, which means that he is the first to say that brain is the command center of the entire body. Then came Galen, who brought in a lot of anatomy, and he was the first to connect parts of the brain with different diseases. Harvey Cushing, way back in 1800, started banking every brain tumor that was operated upon. And then there is this very infamous H series, as it's called, that is Haloverden, who during the World War II collected brains from victims of so-called euthanasia. You know, euthanasia means mercy killing. There it was not really mercy killing. They literally killed people and took out the brains of those who were mentally ill, physically challenged. And that, however, gave us a lot of information about brain malformations. But then, if you look at the traditional brain banking, how it started as an organized collection, was probably very many centuries back, before the Second World War, where you had anatomy museums, and Vogt from West Germany and Yakovlev, who immigrated to the United States, is supposed to have carried with them this whole brain section. And these are from those patients who had psychiatric illnesses and died. And this is what first led to the biological basis of trying to understand disease. But you may ask, why do we need a brain bank? Why don't we just make do with animal models? I mean, you've got so many research things out from animal models. You have an animal model for diabetes, you have an animal model for so many things. Why do we need a brain bank at all? Why don't you just... The fact is that no animal suffers from any neurodevelopmental or psychiatric disorders. And honestly, it's the price we pay for the way our brain has evolved. Okay, so our lower animals just don't develop any of the mania, depression, all of the bipolar, whatever Dr. Rao spoke about in the previous one. So we are very unique, which means that if we want to understand, somebody was asking what is the basis for BPAD, is there a biomarker, how are you going to find it? You will be able to find it not with any animal model. You need actual brain tissues of patients who die of psychiatric diseases. And somebody has to remove that brain at autopsy and somebody has to bank it. So the importance of collecting tissues for research was something that my teacher, Professor Shankar, thought it important in 1985. It took 10 years for him to convince the authorities that it needs to be funded. And finally, in 1995, the brain bank started. So you would tell me that why don't we use chimpanzees? We have a 99.4% similarities with our very friendly chimpanzees. The fact is that although genetically we may be similar, there are still a lot of differences, which is what makes you a human and not a chimpanzee. There are several diseases, like if you take malaria, if you take influenza, the chimpanzees are interestingly not affected. And do you know that they don't even develop neurodegeneration? So all of the Alzheimer's disease, etc., is unique to humans only. So people have looked at aging dogs, people have looked at aging primates, they have looked at polar bears, pigs, etc. Now, interestingly, aged polar bears do develop senile plaques. Plaques are what you find as a hallmark of Alzheimer's disease. But what you never find in them is these kind of tangles. Is that clear? So we are different. So although plaques may be there, they don't have tangles. They also don't have beta amyloid, which is another feature of Alzheimer's disease. If you take tuberculosis, which is the most common disease probably in India, they cannot, rats and mice don't develop tuberculosis. So no animal model for it. So even if you do have information from animals, you can only extrapolate it within certain limits. So world over, banking of brains did start, and there have been several discoveries that have been possible thanks to brain banking. Starting off with, everybody's talking about Parkinson's disease, everybody's talking about dopamine. We know that in Parkinson's disease, a portion of the brain, you're looking at the midbrain here, it's actually the smallest portion, but you can see a black line across. That black line is called substantia nigra, black substance. The reason it's black is because the neurons, nerve cells sitting here, are actually making dopamine. Now you compare it with this patient, you can't see that black line so distinctly. Just tells you neurons there are dead and gone. So dopamine levels have come down, and that is the cause for Parkinson's disease. Who discovered that? Hornikowitz. How did he do it? Because somebody with Parkinson's disease died, donated the brain was removed, and he looked at that entire 1.5 kg brain only to find that it is only in this part that there is pathology. That is the midbrain. How did he know that it is different? Because he had age-matched controls. So if you don't have controls, remember, recognizing disease is impossible. So which do you think is more important? Having brains with disease or brains which are controls? Thank you. Right. So there have been other disorders also where we know a neurochemical basis, like if you look at schizophrenia, we know that monoamines are increased. Again, information coming from bank tissues. Of course, everybody concentrates on Alzheimer's disease, and this is the change that we see if you look at a brain. This is a normal brain. It's a slice. It's like bread loafing a brain. You can see on top is the gray matter and white matter below. Normally, it's very full like this. Now, compare this with this. Can you see that the gyri and sulci are very deep? You can see that the thickness of brain is very, very reduced. Reason for that? All the neurons sitting out here in the cortex is dying. So that's what you see in Alzheimer's disease. But then all of this is only structure, right? Now you need to know what is the biochemistry, only then can you treat with, like Parkinson's disease. You can replace dopa. So this is what people looked at the hippocampus and realized, so this is actually a stain for acetylcholine, and they found that acetylcholine is reduced in Alzheimer's disease, and that is why now they try and treat, they try to replace with cholinergic drugs. Okay, so we also know that amyloid beta is deposited. We know that CJD, you might have heard of CJD, that's Creutzfeldt-Jakob disease, prion diseases. We know now that it's caused by prion, which is intriguingly, although it's transmitted, it is not an infection. It's just an abnormal conformation of a normal protein which is there in the brain. Again, thanks to brain banks. Now, earlier requirement for brain tissue was probably not very high, but now there is an explosion of techniques, right? You have all forms of omics, you have bioinformatics, which can help you to further decipher what is the pathobiology of various disease processes. All you need is, you have the technology, you just need a brain in your hand, right? So, if you want to know about neuropsychiatric diseases, if you want to recognize the pathology, you want to develop effective treatment, what you need is well characterized brain specimens. By well characterized, I mean a pathologist has to look at it and say, yes, this patient had Alzheimer's disease. If we make one mistake in that classification, your science is going to get wrong results. Okay. But the problem, of course, is autopsies, which is how you get brains out after death. World over, it is declining. I'll come back to that a little later. But because of this decline, you know what the world did? They started to network their banks. So if you look at United States, they have 82 brain banks across their entire country. Europe has 38. What happened in India? I don't think you can even see it, but there was only one. Now, what they did was all of these banks, they tried to network together so that they can share tissues, much like blood banks, where I don't have O positive blood, I'll ask my neighbor's blood bank if they have. So that's what they tried to do world over. What happened in India, unfortunately, we had only one bank. Now, you may ask me the question, why should you have a bank at all? You have so many banks across the world. Pick up a phone, ask for 100 grams of substantia nigra of Parkinson's disease. Order. You'll have an Amazon delivery, right? Or Swiggy. Okay. So why do we need a bank at all? The answer is made in India. We are so different. You know, thanks to all of those inherited disorders which are common here because of consanguineous marriages, we have a lot of genetic diseases which are prevalent in our community. For example, we have something called Lafora body disease. We have something called hot water epilepsy. Have you heard of hot water epilepsy? These are patients who, if they have a hot water bath, if they put oil and then a hot water bath, they develop seizures. Unique only to India. We have a Madras pattern of motor neuron disease. You know, I can go on and on. And if you look at Agarwal community, they have leukodystrophy. So each community, if there is inbreeding because of consanguinity, they have a type of disorder. So if you want to study it, you're going to get it only in India. So if you also look at ApoE polymorphism, world over, they'll tell you ApoE4 is prevalent. We looked at our own data and found that no, we are different. So we need a biobank. And that is what Dr. Shankar came up with the idea, like I told you, in 1985. And in 1995, he successfully set up the first and only brain bank for the entire country. So what did he do that for? He said he wanted to help humanity by strengthening the hands that heal by promoting neuroscience research. And that's exactly what he did for the next 2.5 decades. Real banker. It was not for his own research. It was for research for anybody in the country, and we just provided free of cost. Okay. So that was a bridge between the basic scientists and the clinicians. And our job was only to provide characterized specimens in addition to age-matched controls. So where do we get these age-matched controls from? Controls are normal controls. Normal people won't die. But if they die of something like a heart attack, nothing which is neurological, or they die of, in India, maximum deaths are due to absolutely road traffic accidents. And Bangalore has the highest number of two-wheelers. So we have the highest number of road traffic accidents. So we optimize on that also. We use that as age-matched controls. So, of course, you need to remember that donors can be patients with disease, and like I told you, those without disease. And we only take it when there is consent for the same by the family. So you can sign up much before, like you sign up to be an eye donor, an organ transplant donor. You can sign up to be a brain donor too, but keep in mind that finally, when I do die, even if I have signed up, my family can say no. So who decides finally is the family and not you. That's the law in India. Okay, but you need to tell your family, look, this is what I want, and convince them that don't burn, give it for somebody else to live. So those are voluntary blood donors. So what do we do with the brain? We bread loaf it literally. We have two hemispheres. Dr. Srinivas was talking about two hemispheres, which is great, no? So one half, we're going to slice it up like this, remove every anatomical area, put it into Ziploc covers and maintain it at minus 80 degrees. So we have now 2 floors of only freezers, lot of tissues. Now the ethics committee tells me it's precious tissues, but then it's precious only if each of you start to use it. Otherwise, it's just going to be remaining there. So this is just to inspire all of you. Look, This tissue, just use it, it's free of cost. We also collect cerebrospinal fluid from each of these patients, and we take the heart blood and separate it out into serum. So we have paired samples. Now, the other half of the brain, we put it into formalin and we do a histopathological examination to characterize what exactly the pathology is. Because the normal so-called controls, we need to tell you there is no pathology. Okay, so that's characterization. All of these are very well annotated with clinical. If you don't have the clinical data, then the tissue is wasted again. Okay. Now, what Dr. Shankar also passionately believed in is that brains should be used for education. So what he called it was neuroscience literate. He wanted to make everyone literate. So we opened a brain museum. This is a snapshot of the brain museum, which is at NIMHANS. And this is now open to public and to school children. So you can actually see Dr. Shankar doing what he loved most, which was teaching students. So whether it is Abdul Kalam or whether it's this 5-year-old child, he treated everybody alike. And we really catch them young. It's fun to watch all of the kids react to just holding a brain in their hand. Most exquisite feeling. So all of you are welcome to come and visit us. We also have made teaching sets to give it to all institutes across the country. So you may ask, okay, we've had this as a national facility from 1995. 2 decades have gone by. What is it that we have done, right? So this is where we started as one small room. We branched out here, but more importantly, we have 300 plus brains. Dr. Shankar, when asked how many brains you have, he would always say, what is your bank balance? Will you tell me? No. So I also won't tell me. You tell me what you want, I'll tell you whether I have it. Okay, so it's a huge bank now. We collect brains. We are available 24/7 round the clock so that we can do autopsies. Because autopsies don't come and nobody's going to tell you that I'm going to die in another hour's time. Be ready. No, we have to be there. And we have a fantastic autopsy technicians and attenders who are there with me anytime. All right, so a lot of projects supported from across the country, a lot of publications, all of which are, mind you, not our work, it's done by others. And whatever I'm going to show you now is work done by others. So one of the first things that was discovered, and this is an epoch-making discovery, you've all heard of cytochrome P450. Now, why I'm going to go a little in detail is just to give you a flavor of what is possible. Okay, so that should stimulate you to do more. Now, cytochrome P450, you know, is a drug metabolizing enzyme. We always learned about it to be in the liver. But then, because fresh brain tissues were there, Dr. Vijayalakshmi Ravindranath, you might have heard of her, she took the brains and just looked at whether cytochrome P450 was there or not. Because the background to that is we have many psychiatric patients. You give 2 BPAD patients the same treatment, one is going to take a longer time to respond, one will respond quickly. Why? So the answer to that lay in the fact that cytochrome P450 is found in the brain. It's a fantastic discovery, right? So it explained why different patients respond differentially. So this is actually the hippocampus, and that's a fish stain to show the localization of cytochrome P450. Several other biochemical tests were possible because this is fresh tissue maintained at minus 86 degrees. So the myth has always been that after death, when you collect tissues post-mortem, the tissue will die. You've knocked off blood supply. How do you expect anything to be preserved? Which was a myth. But then we had to break the myth. So what is it that remains stable was the question. And we realized that proteins up to 12, actually we looked at across 12 years of collection and found that protein is stable. We also looked at metabolites like glutathione metabolism and saw whether there is a gender difference, what happens to it with post-mortem interval, what happens to it with different types of death. Some people die of respiratory, whereas some die of cardiac. So is there a difference? Another thing that, because everybody has implicated mitochondrial disorder as primary to any neurodegenerative, be it Parkinson's, Alzheimer's, anything and everything now is because of mitochondria. So we could only give you post-mortem tissue if you wanted to look at mitochondria. But the question was, post-mortem, won't the mitochondrial proteins, won't the mitochondrial enzymes degrade with time? So to look at that, it was a very simple study. And we found that it is affected by pre and post-mortem, but up to 12 hours after death, it is still preserved. So if you want to do mitochondrial, you ask for tissues with less than 12-hour post-mortem interval. Okay. Like that, a lot of other things have been looked at, like biochemical, cytokine, proteomic changes, etc. People have also looked at aging changes. We only talk about what happens to neurons. People have actually sat and counted the number of neurons in the substantia nigra. People also tried to look at Parkinson's disease. Now, earlier we used to think that the incidence of Parkinson's in India is very much lower than the West. So the West always used to say that that's because you all don't live long enough. You die of so many things. So Dr. Shankar and Dr. Yasha, who's our neuropathologist, both of them sat and counted the number of nigral neurons. And they compared it with the West. They found that nigral neurons are equal. So there are other factors probably that protect you. And now they believe that it's probably due to turmeric that we eat, a lot of things which are antioxidants in our diet, in our own traditional diet, not your Western diet. They also found, and this is Dr. Jagannath Rao's work, he had taken tissues from us of PD. He found higher number of DNA breaks. He also found a very interesting change of a beta to zeta helix change in aging and Alzheimer's. I think the work that Sir did will take an hour to explain. So that is what he had collaborated with us for. I told you about Lafora body. Now, since we have so many patients in south of India, it also helped to find out what is the genetic mutation that predisposes South Indians to this. But the topic Sir gave me was on neuroinfection. So I'm going to touch a little bit on what we have been able to do with samples in the brain bank. Now, during the HIV epidemic, we did a lot of autopsies. We had almost 300 plus HIV autopsies that we did. And interestingly, what was found was, now with COVID, you have different types of COVID virus. Like that, there are also different types of HIV virus. And in India, interestingly, we have something called subtype or clade C. Whereas entire West, Europe, US, UK, all of them had subtype B. Now, that's not something that we knew in the beginning because all the research came from Europe and UK and they said it's subtype B. Their vaccine that was developed for HIV was again subtype B. Now, why did we look at Indian brains? For one simple reason. If you look at HIV associated infections at that time, the West used to report the complication most commonly was HIV associated dementia. India, no dementia. Now, the reason for that they used to say is all your HIV patients die of TB, they die of infections, and they don't live long enough to develop dementia. Now, that was until one person, Dr. Ranga Uday, he's a molecular geneticist at JNCSR at Bangalore. He asked the question, hey, why do you always blame the host? Why don't you think that maybe there is something different with the virus itself? So he set about trying to prove his hypothesis. It was just a question that he asked. He came to us and asked us for HIV brains. He asked us for blood samples of patients who died of HIV. We gave it to him. And mind you, 99.9% were subtype C, totally different strain of virus. So does that mean that that's the reason why there is no dementia? He still had to prove it, right? So what did he do? He did a very simple thing. Now for dementia to occur, the virus has to enter into your brain. It has to take up all the microglial cells and make it fuse and form giant cells. Now his hypothesis was subtype C is different. It is not doing the same thing. But prove it, boss. Otherwise nobody is going to believe you. Simple thing. He took a dialysis membrane, which is your equivalent to your blood-brain barrier. On one side, he took macrophages in culture. On the other side, he put subtype B virus. Zip, it went right across and made all those macrophages in culture fuse together. Bingo, dementia. What happened when he put subtype C? What do you think happened? Didn't go? It didn't go. It didn't go across as effectively as subtype B. So he said it's a defective chemokine, and that's the reason there is no HIV dementia in India, not because our patients don't live long enough. Fantastic, isn't it? Just because he asked a question and we went ahead and tried to prove it. So that's the moral of the story for all of you. Ask questions and find your answers, or at least attempt to find an answer. But that was, short-lived. 1 year only. Then we got our first case of HIV dementia. All excited. He was a hotel worker, very classical history. went to a patient, went to the whoever is sitting there, took an order. By the time he went back to the kitchen, he forgot the order. So dementia. At that point, every patient who presented like this, the neurologist used to do syphilis, used to test for HIV, and this one was HIV positive. Excitement. But then you had to have the patient die in hospital. You have to, the family has to agree for us to do an autopsy. And we should also be willing to do an autopsy on a HIV patient. With Dr. Shankar, we would do anything. So, incidentally, the patient did die. We did an autopsy. We took out the brain, called up Dr. Ranga over there and said, hey, we got a HIV dementia. He came running. JNCSR is about 40 kilometers away. He came running. Took tissue from us. We were all waiting. He did PCR. He said, if you remember, the virus has two parts, okay? It has a core and it has an envelope. Normal PCRs look at only the envelope, okay? So he looked at envelope and he said, subtype B. Very excited. So see, that is the reason why the patient developed dementia. He didn't have subtype C, he had subtype B. Fascinating, no? Okay. After that, we went on to develop diagnostic kits. So there had to be a quick method of diagnosing HIV. So a lot of people actually sat like COVID testing. You remember during that time, many people came up with kits. So when the HIV pandemic was raging, they also started to make kits which are low cost because the foreign kits were very expensive. But then you need to validate these kits. How are you going to do it? You're going to come to the bank and say, give me so many liters of HIV positive blood. Give me HIV negative also. So all of these have to be banked by somebody so that you can develop indigenous kits. And this kit was recognized by NACO, and now all over India, that is what they use. So a lot of things like cystic a lot of diagnostic kits were developed. We also had a lot of prion diseases, and there, the world over, they're all very scared to do autopsies in prion, but we have done this also. We have done HIV also. We have done COVID autopsies too, still alive. All because Dr. Shankar would say only one thing. Take universal precaution, nothing will happen to you. But then he would also say, see, sinners don't die. You have sinned so much that you will not die. So do. But that is just a joke. So because of tissues that were available, we realized that the prion protein has a pattern of deposition. And that varies with the duration of illness. So then came this explosion of all kinds of omics. I'll start with a disclaimer. I don't understand any omics. Okay, so that's why I was very scared when Sir told me talk about proteomics. The only omics I understand is this. What is this? Yeah, so that's the only thing I understand. But still, when proteomics came up, everybody was interested in trying to look at the brain, right? So we did have Dr. Akhilesh Pandey, who set up the Institute of Bioinformatics at Bangalore. He's from Hopkins. He came to us and said, hey, give me organs. Because at that point of time, there was a human genome atlas, but there was no human proteome atlas. And he took every little organ and he just did the proteome profile, which went into Nature. So I'm just telling you this to tell you that anything is possible. You just need to dream it. But then, what did we have in the bank? We went back and looked. We had lots of infections because many of our patients died of various types of infections. So that since omics came up and we had Dr. Akhilesh Pandey more than willing to do it, all we needed to do is take half kg rabies, 1 kg TB, you take whatever you want, but just do the omics part. But you need to ask a clinically relevant question, not just say, I have a tool, I have tissue, let's put it together. So we tried to, what do we want? We wanted a biomarker which would help probably improve diagnosis in certain conditions, be prognostic, tell how this patient is going to behave, and predictive. It could be any of the three or all of the three, but this was a tall order. We said, this is the only thing we want, we'll give you any infection you want. So we took TB because I think Robert Koch, 1882, discovered the TB bacillus. And we are still having TB, right? By virtue of being born an Indian, we should all have TB. So more than a century passed, more than a century and a half passed, and we are still battling TB. It is probably the greatest mimicker I'm put up some fancy pictures for you just to tell you that it can present with a stroke, it can present with meningitis, it can present with a mass lesion which looks like tumor, it can look like anything. If you talk to a neurologist, whatever the clinical presentation of a patient, they'll first do a test for TB. Okay, so the problem was that in TB till date, we don't have an accurate way to diagnose it. Whatever tests are there in the market, highly unreliable. There is no effective treatment either. We do give antituberculous therapy, but its effectiveness is becoming less and less because your bug is cleverer than you. Don't ever forget that. It has mastered every part of your immune system. It goes exactly where it wants and it survives. It will modulate the host so that it survives. So there is emerging drug resistance. We know that. The vaccine, not very effective. So these were the problems that we had, very simple problems, to which Dr. Pandey said, okay, let's try and look at proteomics. So he did all fancy kinds of things. He told us that if green clusters together, this is a hierarchical map, it's good. It means there is a striking difference and you need to find out what those proteins are. That is big data. He gave us a list of 1,500 odd proteins and he said, choose. How do we choose? So compare it with control, put a fold increase, try and pull that out, find its clinical annotation, and then you take your pick because you're not going to go through all 1,500. What you pick, sheer luck. It's like a needle in a haystack. But we did find several novel markers. Many of them were what was immune modulators. Some of them were HLA related, which tells you what dictates susceptibility. But what was interesting was what was downregulated. Story is not always in the upregulated. Now, several things were downregulated, including synaptic vesicle proteins, which probably is what is responsible for a lot of cognitive changes that we see in patients with TB. So, all of these were promising, but you need to be able to detect it in CSF and you need to do a lot of validation, and a lot of that is still going on. One more example I'll give you, and this is my favorite. This is about rabies. All of you know about rabies, right? If I ask you one thing that you know about rabies, what's the clinical presentation? Hydrophobia. Yeah, it has a very dramatic clinical presentation. They have hydrophobia and aerophobia. You try to make them drink water, they'll go into phobic spasms. You just, fan air across their face, they'll go into phobic spasms. But there is also one more thing that all rabies patients have, and that is all die. 100% mortality. Okay, there is very, very few survivors, and those survivors we don't even know if they had rabies. So they have very distinctive clinical features. Many of them don't even have a history of dog bite, which makes it very difficult to diagnose if they don't. Now you would ask, why can't you just do MRI? Like somebody asks about imaging and psychiatry. Viral infections, do an MRI. The beauty of rabies virus doesn't show anything on MRI. It doesn't even go through your blood. It goes directly into the brain. We know that. So what? If it doesn't go through blood, it doesn't trigger your immune system. So there is no blood test for rabies. You can't do a PCR in blood for rabies. You can't do an antibody test in rabies. So how are you going to diagnose? Wait until there is hydrophobia. And if the patient dies, you know it was rabies. It's that sad. So post-mortem, looking at the brain at autopsy remains unfortunately the gold standard for diagnosis. A lot of things we know, how the virus enters through a bite, how it goes right up to the brain, all of that we know, but we still don't know why there is hydrophobia. We don't know why everybody dies because there is no brain edema if you look at a patient with rabies, but we know they all die. You can have a dog bite and not develop rabies immediately. The incubation, which is time from bite to rabies, can go from 6 days to 6 years, by which time you would have forgotten that you had a dog bite. So what's the reason for all this? There is no answers. So we thought, let's ask proteomics if they can give us any answers. But first we looked at literature. We do know that incubation can be due to type of virus. It can be, how much of virus got in, how close the bite is to the brain, etc., etc. So we tried to look at the brains that we had, and this is an immunohistochemistry where we've tried to map where the rabies virus is. And this is phenomenal because wherever the brown is where the rabies is. And I could have taught anatomy if Dr. Srinivas was here. That's the hippocampus. This is the basal ganglia that he was talking about. It's like a neuronal tracer. Every neuron in the brain will contain tons of viral antigen, but the brain will show absolutely no response, no inflammation, no edema. Patient dies. That much we are certain of. But when we try to map it, so red is where maximum virus is. So when there is a very short incubation period, it hits the middle of the brain. Okay, it doesn't hit the top part of the brain. So if it hits the middle, that's the brain stem, that's the most critical area. Knocks off respiration, knocks off your cardiac center, death. But if there is a longer incubation period, it probably, we thought, loses its way. Depends on the route. Like sir was saying, you want to reach the airport early, you take a... He said that. Okay. So the shortest route you take, you will hit critical areas faster, death. You take a much longer route, you're going to take a longer time to reach. So it was as simple as that. Then we tried to ask what's the cause of death, because that was $1 million question. World over, nobody could answer. And at that point of time, all viruses, they said, causes apoptosis, means the cell in which it is sitting dies. So we tried to look at rabies, and we looked at humans, we looked at animal, dog brains, etc. No apoptosis. There's no brown out here. The only brown you're looking at, interestingly, is in the few inflammatory cells that came up. Isn't that fascinating? It makes sense because the virus doesn't want to kill its own host cell. It's not in its interest. If the host cell dies, it can't survive. It has to remain within a neuron. But what it did do is knock off all your immune responses. Any inflammatory cells, it sent it packing. Fantastic strategy, isn't it? Only one flaw in its strategy, the human dies. So, but why the human dies, we still don't know. So, if the neuron is not dying, is it dysfunctional was the question. It's anatomically normal, but is it dysfunctional? We couldn't answer that question. So, we looked at proteomics. Lot of, again, 59,000 odd proteins. What was upregulated were all the synaptic proteins. Okay, what was upregulated is transport and entry. So all these proteins are used by that virus, normal proteins, to enter in, like Tarzan, What it knocked off was apoptosis, which we already knew, and all of your inflammatory mediators it knocked off. So it gave us a lot of answers. It didn't still tell us cause of death. But then we have that 59,000 remaining. No, we have to look through all those proteins. A third question, which is a burning question for a clinician, is 1/3 of our patients don't come with hydrophobia. They don't remember that there is a dog bite. So they present with something called Guillain-Barré syndrome. What is that? These are patients who present with ascending paralysis. First, lower limb, they can't walk. Then they can't breathe. Arms paralyzed. So it is ascending. Now this is caused by an autoimmune disease. And when it's caused by an autoimmune disease, you treat the patient walks back home. The same thing exactly is mimicked by rabies. And if it's caused by rabies, patient dies. So in the clinic, for a clinician, he needs to know, is this rabies or is this Guillain-Barré syndrome? Because if it is Guillain-Barré syndrome and there is respiratory paralysis, you go all out, you intubate the patient, just wait until it resolves. Patient will walk back home. If it is rabies, whatever you do, so no use. But there is still no test to know whether it's rabies or not. There is no anti-mortem diagnosis. No PCR in blood, can't do any CSF test. You just have to wait. If a patient with GB syndrome dies, it's rabies. A patient with GB syndrome walks home, it's not rabies. But that's not something that a clinician wants. They want answers. They want bedside tests. They want to know now, is it rabies or not? So we looked at a lot of proteomic data. And interestingly, there are a lot of markers. This is just recent. We have not yet validated this, but a lot of promising things that are going up exclusively in GB syndrome and going down in paralytic rabies. So this is something that you should validate and develop into a bedside test. Wouldn't that be great? So that's the power of your omics. We had lots of infections. We did omics for everything, particularly with the HIV. We had Cryptococcus, Toxoplasma, a lot of things going up, a lot of things going down. But it's not going to give you a full answer simply because these proteins can be from the host itself, all of the cells of the brain, or it can be from the bug. That is something that needs to be dissected before you can use this either as a predictive, diagnostic, or prognostic marker. So that is $1 million question, and you need to separate this out. And for that, you need your clinician and basic scientists to sit together and talk. So just having technology is not good enough. Just having the tool is not good enough. What's important is to know what question to be asked. And that is something that a clinician will best tell you. So sit together. Only then will you have translatable research. Otherwise, it's like those 6 blind men trying to look at an elephant and describe parts. That's what omics does to you. So, in summary, I think bank tissue does enable very crucial advances in understanding and treating. But what you need for that is very well preserved tissues. You need tissue banks, you need fluid banks, but you also need people like you to use them. And you need to educate the public. So that's what I've tried to do. This is a team from Nimhan's Institute of Bioinformatics and the Yenipoya now, which is in Mangalore, who have a beautiful proteomic facility. And those are the ones who have done it. So I just have a few more slides. So that's because I need to tell you that although we have this brain bank, there are a lot of operational challenges. And what is that? It is, I told you, there is a very alarming decline in autopsies. So you need to be asking for tissues. You need to enthuse your own clinicians and your own pathologists to be around for doing the autopsies. But more importantly, all of us should start thinking of banking. We also need to think about being donors towards science research. And that has to start with us. So before we ask somebody else, we ourselves should be convinced that this is what is needed. So how are we going to meet this increasing demand and lowered supply? So for this, we have of course missed lots of opportunities where we could have banked brains. The reason we didn't is because many medical colleges, unfortunately, are no longer doing autopsies. They don't want to do it. It's a dirty thing to do. It's a smelly thing. Who is going to do it? We're not going to get any money for that. We're not going to get any incentive for that. It is for somebody else to do research. Why should I? I think that's a mindset we need to get out of if we want to support each other in research. So we need to increase donations. So you need to increase public awareness. You need to enhance autopsy rates. You need more bankers. And we should also probably pool resources. So if you remember, we had just that one brain bank in India. So we have now started a Network India initiative. We've got 3 more banks, one up in north, that's PGI Chandigarh, where I've helped to set up a bank, KEM Mumbai, and AIMS Bhubaneswar, where satellite banks I've tried to set up so that we can optimize. At least in these 4 areas, if we start collecting, we can share resources. We went across and tried to get China, Sri Lanka, and Japan also to collaborate and see whether we can have an Asian bank. A lot of hurdles, but we hope to get there. So that's the roadmap, and I'm showing you this as the last slide because this is a favorite slide of Dr. Shankar. He would always end every lecture on banking, brain banking, with this roadmap, and I must say that this holds even today. He did every one of these. He would encourage sharing. He would encourage innovation. So we are there for you. All you need to do is come up with an idea and be passionate enough to answer that question. So that's our team at the Brain Bank, without whom none of our banks would really be possible. This is Professor Shankar, and to me, he's like a banyan tree. You know, that Kalpa Vriksha, which we talk about, it's supposed to provide fulfillment and enlightenment of all of those who seek its shade. And that's exactly what Sir did, to have so many results, to have so many people doing neuroscience research. We have this one man to thank. And this is, I think it's a dedication to Sir, whose contributions were larger than life. This is what he would always say: do something, either lead, follow, or get out of the way. On that note, I'll end. This is a poem that you can read while you think up questions to ask me. Thank you very much, sir, for this invitation. It's been lovely being here and talking to all you energetic young minds. I'm happy to take questions. I think at the end of the day, they are tired. Okay, thank you very much for the patient hearing and have a great workshop. Yes, there is a question. Please. Yes.
Like we can see a few members saying they quite some posting to their body. And during that time, they speak different languages. Is that related to scientifically or is that related to motivation?
No, say that again. When they die?
Not that.
Huh.
My husband we said that when the person dies, it's a nice moment. And those memories transfer to some other person. He said that then I quite some posting. Is that really true or is it only my trust?
Honest answer to that is we don't know. You know, a lot of things that is there in mythology now is getting proved with science. So I don't want to dismiss anything as myth unless you can prove that it is not. So it might be true. It's like if you all believe in collective consciousness. Do you? If you do, then consciousness cannot be in each of us as individuals, right? It must be something higher, which is where all of the magnetic field and all of that comes in. So I'm sure there is something to this. We're literally talking about soul going out of the body and maybe true. So these are called, a lot of information is coming from near death, where somebody who almost is dying and then comes back to life says that, yeah, I could see people who were around me, I could see my family crying. So is that imagination? Is that true? We don't know. But there seems to be a move towards believing that that is true, waiting for hard science to prove it. But I don't think it can be dismissed. Yes.
My question was
Okay.
the word of was very nice. But isn't it currently trying to get
Yeah, good question. So there are a lot of omics, including metabolomics, transcriptomics, genomics. Now, in genomics, suppose you find a gene, are you sure it's going to make the protein? So which would you prefer? Each one has its own. Correct? Yeah. Absolutely yes. Absolutely yes. So we have been looking at metabolomics. I didn't bring that in, but each of it is giving an answer which you need to synthesize to make sense out of it. But tissue is there. Whether you want to look at the metabolites level, whether you want to look at protein, whether you want to look at, now there's a lot on miRNOmics. There is single cell RNA-seq. The world is just full of technology, but you need to synthesize. Yes, it will give enormous information, but question should be right. That's the only point I stand. There is one question from the back. Yes. 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 it's a very good question. SUDEP is something that world over they are looking at. Structurally, we have never been able to find anything going wrong. All right. So what they think now is that it's at the metabolite. Now, metabolomics they are trying to look at, but we have not yet got data on that. The other thing they are thinking is whether it's a biochemical change, as in it's a neurochemical. So it's a noradrenergic or adrenergic surge, which happens just prior to. We don't know. So yes, there is work going on, but currently, as far as I know, there are no answers. But lot of interest in SUDEP.
Thank you so much. That was a very fantastic lecture about the brain bank. I just have one question because you are quite around your data of normal brains. As you said, you also have brain bank for normal brains. So I just wanted to ask if, for example, somebody has practiced dance for 30 years. So there will be some structural changes in the brain when projects or something like that, or musicians, or athletes. So have you tried to identify some kind of special tools in such?
Wow. Lovely question. So I'll answer that in two parts. First off, getting history of that kind in India, extremely difficult. But then right now we have an ongoing study. It's called the C-Veda study, where they are trying to look not with brain pathology, that is going to be added in the next phase. They have imaged with a 3 Tesla MRI from birth. So it's called from cradle to grave. Lot of volunteers, and they have imaged it from cradle till death. Now, in the second part, in the first part itself, they've collected enormous amount of historical data. Now, because these patients, they are not dead, they're all living well. So now they are trying to use AI and ML based algorithms to try and map groups of things, like those who are, right now they're looking at sports. They've not yet gone into music, and they are also looking at people who have been meditating in the Himalayas. They've got a lot of these people who have signed up. That's right. Yeah. Correct. We have a music division. Dr. Shantala Hegde is looking at that. And she has been looking at autonomic function in them. She's looking at EEG changes in them. She's interestingly looked at, you should bring her, I think, to give the talk. Two groups. One group are those who are trained musicians, and they are given happy ragas. And if they don't like, let us say, Western pop, they're given Western pop music to see what's happening in their brains. She's even done the reverse. Give them music they like. She's done the same thing on those who have not been trained. She's analyzing data now. She's got electrophysiological, autonomic, as well now as MRI data. So we are at that flux where we are still gathering data. It will be. So, he's listening. We'll be very happy. We'll be more than happy. Yes. So the second part of it is that we need people like you who volunteer to, who enlist. This happened with the nun study in the United States. So if a lot of work had been done on dementia brains, which was terminal after death, we had no clue whether how that brain was functioning during life, right? So yeah, yeah, yes, yes. Lots of things can be done. Lots of things, because you have technology now and you have the enthusiasm and the bright brains out here. I think there is no limit. A lot of things can be done. But all of you need to ask questions. Thank you. Thank you. Thank you, sir.
Thank you, Dr. Anta Madhavan. It was wonderful lecture. Just formal thanks from the Institute for accepting our invitation and being here and giving your insight into the brain bank and concluding the day. Overall conclusion for the day, we started with a clinician from AIMS, New Delhi. giving the vision of India and AI and ML role in the overall technology scenario in biology. And then we hear with specific brain bank, which is very specifically targeted towards finding the clues from the human brain. So in between, you had speakers, an engineer's version of the brain modeling, and then we had a psychiatrist's version of looking at brain mind, how mind thinks of our own brain attitudes, and then finally a brain bank. So you could see the diversity of the talks you had from morning to evening, and we are very sure by the end of the workshop you will be having a total integration of all these data with the new technology of AI and ML coming together. Just to say, all these, except for the first introductory talk by Dr. Srinivasan, the other ones were all has the possibility of using the new technologies of AI and ML. Call it Dr. Say Srinivas Chakravarti, where he is totally using the say algorithms. You have clearly seen what can be done, and then can AI be integrated into the psychosis, so bipolar disorders or acute psychosis, or and here this is a clear case where we have all the omics data, and it is to use these technologies of AI and ML, sit with engineers, can we integrate metabolomics into the glycomics, into the genomics, into the proteomics, because all were worked in silos. As madam has clearly said, a gene is expressed. Is it overexpressed or downregulated or upregulated? If so, is it shown in proteomics? If not, is it influencing any metabolite? Now it is time, I think, to put it into this AI and ML and see how these changes can be brought to a conclusion. 1500 genes, 50,000 plus proteins, change upregulated or downregulated 1500 genes, and now metabolomics is coming up. Every metabolite is being estimated. So I think it's high time for us to integrate all this, sit with algorithm people to develop a new algorithm and then find out some clues where we are conclusive. And also I think I need to thank Dr. Antamandavan to bring out things which were forgotten. Rabbis, I think nobody is now interested in doing research, but when I look up at that data now, what I say is totally a new way of understanding the disease. What this virus can do is coming out with the hidden samples. Likewise, once the bank is created, I think there will be more and more opportunity, and I'm very happy the way respondents or questions have come up to see from the students, igniting minds. I'm seeing our own culture being brought in and asking questions. This is a good initiative, and this is a good change I'm seeing in the conference attitude of the students moving down the line. I hope this kind of crosstalk conferences will bring in the required, say, questioning capacity, and then once you question, there's definitely you'll find answers. With these words, I thank all the speakers wholeheartedly for accepting our invitation and being here, and I thank Pro Chancellor Dr. Jagannath Rao Garu to making this happen in reality, and I thank convener Vasja Madam to take up this whole responsibility and to implement it. Let's move ahead. We have say next days to have both practical and hands-on things going on. Thank you one and all.
I would like to thank Anita Mahadevan ma'am, as well as I would like to thank our Dean R&D Research and Development, Professor Jaykumar Singh sir, for briefing the sessions. And dear participants, ladies and gentlemen, and today the session, we can call it a day for today's session. And tomorrow plan of schedule is sharp 9:30. Our session starts with two speakers, that is Professor Shyam Divakar, Professor and Director, Amrita Mind Brain Center, Amrita Vishwavidyalayam, Coimbatore. And another speaker session is by Dr. Alex Rebello, neurologist, AIMS, Mangalgiri. And then followed by lunch and followed by the visit to Brinda Brain Care Institute, Guntur. And the participants are requested to attend morning session as a must. The attendance will be considered, and those who participate in the morning session are allowed to visit of Brinda Institute. And we request you to be on time by tomorrow 9:30. So let us call it a day. Thank you so much.
navigation, knowledge scans, also neuroimaging, and also there
The charts are not beautiful, right?